For centuries, scientists believed they had the age of our planet figured out, about 4.5 billion years. But now, new discoveries are forcing us to question everything we thought we knew. Evidence has begun to surface suggesting that Earth may have a missing age, a hidden chapter of time erased from the geological record. This mysterious gap could stretch across hundreds of millions of years, a period when colossal events shaped the planet in ways we're only beginning to imagine. Did continents rise and vanish without a trace? Did life take its first fragile steps long before we assumed? Or is there an even deeper, more unsettling secret buried beneath our feet? Before we begin, let us know in the comments below where in the world you're watching from and what time it is there. Now settle in for a journey to the prehistoric era on Earth. Mass extinctions are like sudden twists in the grand story of life on Earth. They tear down the rules that once held steady and scatter the pieces of the game into chaos. Some creatures lose everything, wiped out forever, while others, often small and unnoticed, are handed a chance to rise, adapt, and conquer the new world left behind. When the mighty dinosaurs vanished in a single sweeping tragedy, our distant ancestors, tiny, fragile, and easy to overlook, found their moment to endure, to crawl through the shadows, and to begin the long climb toward what we now call humanity. To understand this tale of death and survival, imagine standing on the edge of time itself, looking back across vast eons. Mass extinctions are not simple endings but colossal turning points. They are not gentle declines. They are brutal, sudden crises that, on the scale of geological history, last for no more than a blink. A true mass extinction is defined when at least 3/4 of all species living on Earth vanish. That means forests, insects, reptiles, fish, corals, and even the smallest forms of plankton all share the same grim fate. The world goes quiet, and the stage of life is cleared for something else to take over. In the last 500 million years, life has stumbled through 5 such great extinctions. Each one was like a hammer falling from the sky, shattering the balance of nature. In some of these dark chapters, as much as 75 to 90% of all living things disappeared. To put it in perspective, more than 99% of every plant, animal, and microorganism that has ever existed on Earth is now gone, leaving behind only bones, shells, and faint imprints pressed into ancient rock. Extinction is the most permanent rule of life. It is not a rare exception. It is the fate of nearly all living things. Yet, as grim as these mass die-offs sound, they were not only endings, they were also beginnings. Each catastrophe opened the way for something new. When one branch of life was cut down, others spread into the empty spaces. The seas, the skies, and the land all shifted and were forced to change. Evolution does not stop in the face of disaster. Instead, it finds new paths. After all, without the fall of the dinosaurs, mammals, creatures small enough to hide in burrows and nests, might never have had the chance to rise into the rulers of the Earth. The first great extinction struck during the Ordovician period, about 444 million years ago. In those distant days, most life was still confined to the oceans. The land was barren, holding only the earliest moss-like plants, while seas were full of strange shelled creatures, corals, trilobites, and the first primitive fish. A massive glaciation event began when huge amounts of carbon dioxide were pulled from the atmosphere, cooling the planet. Great ice sheets spread across the land, covering an area 3 times larger than present-day Antarctica. This sudden chill caused the seas to drop and habitats to shrink. Cold waters spread where warm waters had once been, and countless marine animals were unable to cope. Then, as the ice melted and waters rose again, oxygen levels in the seas collapsed, and toxic metals dissolved into the currents. By the end, around 85% of all living species had been erased. The next great disaster unfolded in the Devonian period, beginning around 383 million years ago. By then, life was far more advanced. Plants had begun to spread across the land, forming the first forests, and fish had grown diverse, with some developing strong fins capable of crawling onto the shore. Yet this flourishing world was struck down. Waves of volcanic eruptions poisoned the oceans and suffocated them of oxygen. Entire reefs of coral and countless fish species vanished. The Earth also entered another chilling freeze, but unlike the long glaciation of the Ordovician, this one was shorter, lasting less than a single million years. Even so, it was long enough to claim around 75% of all species. The deadliest extinction of all came later, about 252 million years ago during the Permian period, on the eve of the Triassic. This calamity was so overwhelming that scientists call it the Great Dying. More than 90% of all species were destroyed. Forests turned to ash and needed more than 10 million years to recover. Oceans lost most of their life, with oxygen falling by nearly 76%. The cause was massive volcanic eruptions in what is now Siberia. These eruptions spewed out towering fountains of lava and released billions of tons of carbon dioxide and methane into the air. The greenhouse effect grew unbearable, heating the Earth by several degrees. Acid rain burned the soil and poisoned rivers. The very rocks themselves cracked and decayed under the assault of chemicals. The oceans became hot, toxic, and suffocating. No other catastrophe in Earth's history has ever matched the horror of this one. It was as if the planet itself tried to destroy every living thing clinging to its surface. Roughly 200 million years ago, another wave of extinction arrived, striking between the Triassic and Jurassic periods. This time, volcanic activity once again filled the skies with carbon dioxide. Global warming spread across the continents, and the seas turned acidic. Many creatures of both land and sea perished, with up to 80% of species lost. But out of this devastation, a new group of reptiles emerged as rulers: the dinosaurs. They filled the empty landscapes, growing larger, stronger, and more diverse than anything before them. The fifth mass extinction is perhaps the most famous of all, not because it was the worst, but because it ended the age of the dinosaurs. It happened 66 million years ago, at the close of the Cretaceous period and the dawn of the Paleogene. For 165 million years, dinosaurs had ruled every continent, from the smallest chicken-sized hunters to the gigantic long-necked sauropods that stretched longer than buildings. Then, in a single day of fire, that reign was broken. A massive asteroid, miles wide, slammed into what is now the Yucatan Peninsula in Mexico. The impact unleashed more energy than all the nuclear weapons humanity could ever build. Forests across the planet burst into flames. A cloud of dust and sulfur wrapped the Earth, blocking sunlight for months and plunging the world into a chilling darkness. Plants withered, herbivores starved, carnivores soon followed. Nearly 65% of all species disappeared. Dinosaurs that had once seemed invincible vanished forever, except for the small feathered ones that had already begun the slow transformation into modern birds. The end of the dinosaurs was not only a scientific event, but also a cultural echo. It reminds us of fallen civilizations, of lost empires that once seemed eternal. Humanity had no part in their downfall. The last non-avian dinosaur died around 60 million years before the first creature that could be called almost human walked the Earth. Yet their story lingers, carved into our imagination, inspiring myths of dragons and giants. Before diving into the world that replaced them, it is worth imagining what Earth looked like during the height of the dinosaurs. Continents were arranged differently, clustered into shapes that are unfamiliar today. The seas were higher, flooding wide plains. Tropical forests spread far into the north. The air itself was thicker with carbon dioxide, making the climate warmer and wetter. Dinosaurs of all shapes and sizes dominated. Some flew through the skies, others thundered across the ground, and others still ruled the oceans with terrifying jaws. For 165 million years they were masters without rival, shaping ecosystems in every corner of the planet. Then, in the blink of geological time, they were gone, and in their absence, small creatures that once lived in fear found new space. Tiny mammals, which had mostly hidden underground or in trees, feeding on insects and seeds, now spread across the empty landscapes. They grew larger, bolder, and more diverse. From these survivors, lineages would eventually rise that led to apes, and from apes to us. The end of one empire gave rise to another. The reshuffling of life's deck brought both destruction and opportunity, pain and promise. It was the pattern of mass extinction, repeating as it always has, shaping the fragile yet unyielding story of life on Earth. We're in the Cretaceous period, a little more than 65 million years ago, at a time when the world was both familiar and strange. From far above, the Earth looks somewhat like the planet we know today, but the shapes of the lands and seas are still in the middle of transformation. The great supercontinent called Pangaea, which had once brought almost all the dry lands together into one gigantic, has already broken apart. It has been divided into two immense continents. One is known as Laurasia, and the other is Gondwana. These land masses will continue to drift slowly, carried along by the restless plates of the Earth's crust, and in time they will form the continents we recognise today. Laurasia itself will split further, creating a gap that will open into the wide stretch of water that we now call the North Atlantic Ocean. Though these changes take place over millions upon millions of years, they are already shaping the face of the Earth into something closer to what we see on modern maps. The general climate of this ancient world is hot and heavy with moisture. The air carries warmth across the seas and lands, and the atmosphere feels thick with humidity. The sea levels are high, covering large areas of what are now lowlands and coasts, leaving shallow seas that teem with life. On land, plants grow in astonishing abundance, spreading their green cover across vast territories. Ferns thrive as they have for hundreds of millions of years, their delicate fronds unrolling toward the sky. Conifers, with their tall trunks and needle-like leaves, form forests, and alongside them stand flowering plants, which are newcomers in the history of vegetation. These flowering plants are quickly becoming dominant, aided by the buzzing work of insects that carry pollen from one bloom to another, ensuring their survival and expansion. The landscape, both lush and diverse, provides food and shelter to an array of creatures, while in the seas and oceans life grows to enormous proportions. This is truly the age of giants, a time when many animals reach astonishing sizes, whether they live on land, swim through the water, or fly above in the open sky. In the oceans of the Cretaceous, a family of immense marine reptiles reigns supreme. They are the true masters of these waters, filling every corner of the seas, from the shallow coastal reefs to the deep and open expanses far away from land. Among these rulers are the plesiosaurs, whose long necks and powerful bodies glide smoothly through the water. Unlike modern fish, plesiosaurs do not use their tails for swimming. Instead, their four limbs have been transformed into great flippers that beat through the waves in powerful strokes, propelling them with grace and surprising speed. They feed on ammonites with their spiraled shells, on swift-moving fish, and even on other reptiles of the sea. These creatures, with their unusual method of swimming and their sharp teeth, are a formidable presence in this oceanic world. Sharing the waters with them are the mighty mosasaurs, which are close relatives of lizards and monitor lizards. Their long, streamlined bodies can range from just over 1 meter to more than 15 meters in length, meaning from about 3 feet to nearly 50 feet. With their elongated, vertically flattened tails acting as strong propellers, they surge through the water with ease, chasing prey with deadly determination. Their limbs, like those of the plesiosaurs, have become flippers, perfect for slicing through the waves. Mosasaurs feast on fish and other reptiles, making them some of the most feared predators of their time. Unlike fish, however, all these reptiles breathe with lungs rather than gills, meaning they cannot remain underwater indefinitely. They must rise regularly to the surface to draw in fresh air before diving again into the depths. Some species, like the pliosaurs, have nostrils that are so small and specialized that they cannot rely on them in the same way. Instead, these creatures swim with their mouths half open, letting water flow inside. This water passes through openings in the palate and exits through the nostrils, where the scents are analysed, giving the pliosaurs a remarkable sense of smell to detect prey or danger around them. Alongside these sea lords are other remarkable animals that add to the richness of Cretaceous oceans. Marine crocodiles glide through the waters, their long jaws snapping shut on unsuspecting prey. Flat-bodied snakes slither through the waves while sea turtles drift gracefully between the shallows and the open sea. Among these turtles, one stands out as extraordinary: the gigantic archelon, the largest sea turtle known to have lived alongside dinosaurs. This remarkable creature grows to more than 4 meters in length, which is around 13 feet, making it larger than most humans could ever imagine a turtle to be. With its massive body and strong beak-like mouth, Archelon is able to crush the hard shells of ammonites, belemnites, bivalves, and various other crustaceans. It also feeds on tough seaweeds and grasses, tearing them apart with its powerful jaws. Its skeleton is surprisingly light for its size, a design that allows it to remain buoyant in the water. With its broad, muscular fins, Archelon moves swiftly through the ocean, quick enough to chase prey and nimble enough to flee from its most dangerous enemy, the mosasaur. Few sights could be as awe-inspiring as this giant turtle gliding silently through the prehistoric seas. Another formidable predator of these waters is the Metriorhynchus, a kind of crocodile that is fully adapted to marine life. Unlike modern crocodiles that spend much of their time on land or in rivers, Metriorhynchus lives exclusively in the sea. It can grow up to 3 meters long, or about 10 feet, making it a smaller but no less dangerous hunter. Its body is built for speed, equipped with a tail shaped like a crescent moon, allowing it to dart through the waves with remarkable efficiency. Its legs have become short, flat fins, with all the fingers of each limb fused together into a single membrane, making them powerful tools for swimming. This creature, with its sharp teeth and sleek body, is a true predator of its time. But the seas are not only the domain of the giants. Alongside these titans live countless smaller creatures that form the backbone of marine life. Among them are the rudists, a family of bivalves that thrive during the age of the dinosaurs. Some rudists live alone, standing upright on the seafloor, while others gather in great numbers, building dense colonies that resemble reefs. These reefs become bustling underwater neighborhoods, offering shelter to fish, shrimps, sea slugs, and many other small animals. Rudists feed in a simple but effective way. They filter seawater, capturing the plankton and tiny particles drifting within it. Plankton is more than just food. It includes creatures like the foraminifera, which are single-celled organisms protected by delicate shells that coil into beautiful spirals. Though each foraminifer has only one cell, some can grow to an impressive 8 centimeters across, which is about 3 inches. These small but vital creatures play a key role in the ancient oceans, forming the base of the food chain and supporting the giants above. Of course, fish themselves are plentiful, darting through the waters in shimmering schools. This is the time when many of the ancestors of modern fishes begin to appear, though they are not yet as dominant as they will one day become. Their scales glisten in the light filtering down through the waves, and their quick movements make them difficult targets for the larger predators that pursue them. Swimming among them are mollusks, some of the most remarkable and diverse creatures of the sea. Ammonites, with their iconic spiral shells, are especially abundant during this period. Their shells are divided into a series of chambers, with the living animal occupying only the last and largest one. By using a small tube called a siphuncle, the ammonite controls its movement, adjusting its buoyancy by filling chambers with gas or liquid. Its tentacles, ringed with suction cups, reach out to seize prey. Once caught, the prey is crushed by the ammonite's powerful jaws, which resemble the beak of a parrot. During the Cretaceous period, there are more than 5,000 species of ammonites, filling the oceans with their coiled shells and varied forms. They are both hunters and hunted, essential to the balance of life in the seas. Beside the ammonites swim the swift belemnites, which are cephalopods with an internal shell rather than an external one. Their streamlined, torpedo-like bodies make them efficient and fast swimmers, capable of reaching high speeds. Belemnites are fierce carnivores, chasing fish and other small creatures with their 10 tentacles. Unlike the suction cups of the ammonites, the tentacles of the belemnites are armed with tiny hooks, perfect for gripping and holding wriggling prey. Once caught, the unfortunate victim is swiftly devoured. These predators, though smaller than many of the giants of the seas, are powerful in their own right and play a vital role in maintaining the rhythm of life beneath the waves. The skies of the ancient Earth were not empty. They were shared by 2 very different rulers of the air: birds, the ancestors of the winged creatures we still know today, and the strange and spectacular flying reptiles called pterosaurs. Pterosaurs were not dinosaurs, though they lived alongside them, and they had wings made from stretched membranes of skin and muscle instead of feathers. They glided, soared, and sometimes flapped powerfully above seas, lakes, forests, and plains. Among them were species that could be as small as a sparrow, and others that grew to truly unbelievable proportions. One of the most extraordinary was a giant named Quetzalcoatlus, whose wings could stretch as wide as 12 meters, which is about 40 feet. This was a size so enormous that when such a creature passed overhead, its shadow could cover entire herds of animals below. It was shaped by the gigantism of its time, when nature seemed intent on pushing animals to their ultimate limits in both size and variety. Despite their immense wings, pterosaurs were not swimmers. They could not dive deep beneath the surface like today's penguins or cormorants. Instead, they became skilled at fishing while in flight. With elegance and precision, some of them would skim just above the waves, dragging their long beaks lightly across the surface, ready to snap up an unsuspecting fish that came too close to the light. This technique made them superb fishers of the skies. Their beaks varied widely depending on the species. Some had narrow jaws lined with rows of long, needle-like teeth, perfect for trapping slippery prey or filtering tiny organisms like plankton from the water, almost like the baleen of a whale. Others had smooth, toothless beaks that looked more like the beaks of scavenging birds, allowing them to tear at carcasses or steal food from weaker creatures. Pterosaurs filled many different roles in the ecosystems of their age, just as modern birds do today. While these winged reptiles ruled the air, the ground below was the domain of dinosaurs. Dinosaurs were the lords of the land, and their dominance was written across every continent of the earth. Their incredible diversity, their size, and their strength gave them unmatched control over the habitats they lived in. From the smallest nimble hunters that could dart between ferns and bushes, to the towering plant-eaters whose heads could sway among the treetops, dinosaurs embodied the spirit of the Cretaceous period. They carried themselves like living dragons, with jaws filled with sharp teeth, claws curved like sickles, and eyes that burned with the light of survival. The most awe-inspiring of all were the giants of the plant-eating world. Among these were Diplodocus and Brachiosaurus, creatures so immense that they remain the largest land animals to have ever walked the earth. They reached a size that may have brushed against the very limit of what land-based life can achieve. As animals grow larger, their skeletons must grow stronger. Bones lengthen, but they must also thicken to support the increasing weight pressing down upon them. Legs grow more massive, but heavier limbs add more burden, creating a natural barrier to unlimited growth. Yet evolution pushed these creatures to the edge of possibility. Their ribs and vertebrae were filled with hollow spaces, lightening their skeletons while still keeping them strong. This clever natural engineering made their massive frames possible, but still, it is believed that no dinosaur ever grew beyond 40 meters in length or 100 tons in weight. The Diplodocus, one of the most famous of these giants, could grow to 27 meters, nearly 90 feet. Its body was a marvel of adaptation. Its skull was long and narrow, with a snout that jutted forward like the prow of a ship. Unlike most animals, its nostrils were set farther back on its head, above its eyes. Air passed through winding internal channels that helped it carefully analyze scents in its surroundings, perhaps warning it of predators or guiding it to fresh vegetation. Its teeth, small and spoon-shaped, were neatly arranged at the front of its jaw, perfect for stripping leaves and soft branches. When they wore down, new teeth grew to replace them, keeping the animal always ready to feed. The pelvis of the Diplodocus was massive, built from 5 fused vertebrae that acted like a central pillar to support its colossal bulk, which weighed about 10 tons. Its most striking features were its immensely long neck and tail, which balanced each other like the arms of a giant scale. The neck was made of 19 vertebrae and could stretch as long as 15 meters, nearly 50 feet. The tail ended in a whip-like taper that may have cracked through the air as a weapon, striking predators or signaling to others of its kind. Life as a giant had advantages, such as access to higher food and protection from most threats, but it also came with costs. To maintain such a body, the animal had to consume vast amounts of vegetation every day, and it had to support its crushing weight with every step it took. The plant-eaters shaped the land, and in response fierce carnivores evolved to hunt them. Among the most iconic was Tyrannosaurus, a predator that became a legend of its time. With its bone-crushing jaws, powerful legs and keen senses, it stood as a symbol of predatory perfection. Yet it was not alone. Other predators prowled the Cretaceous landscape, some equally powerful though less known today. The Spinosaurs were among the most remarkable of these hunters. They were different from other meat-eating dinosaurs because of their crocodile-like snouts, filled with many small teeth, perfect for gripping slippery fish. Their thumbs carried enormous claws that could slash through flesh or pin struggling prey. One such spinosaur was Baryonyx, whose name means heavy claw. This creature stretched nearly 10 meters, about 30 feet in length. Unlike Tyrannosaurus, it walked more lightly, balancing on 2 strong legs. Though it was not a fully aquatic animal, it spent much of its time near rivers and lakes, where fish swarmed in abundance. Its powerful arms could grasp and hold prey, while its elongated jaws clamped down with deadly precision. Its long tail provided balance, helping it move swiftly across land or while wading in shallow waters. Baryonyx was no specialist. It ate fish, scavenged carcasses, and even hunted smaller dinosaurs. Its versatility made it a formidable survivor. Around these mighty beasts, the world was alive with creatures often overlooked. Insects thrived in unimaginable numbers, crawling over soil, buzzing through the air, or burrowing into bark. It was during this age that familiar insects like bees, ants, and butterflies first appeared. They fluttered and crept across a world newly clothed in blossoms. This was the time of the first true flowers, which resembled today's magnolias with their large, showy petals. Over time, flowers became more specialized. Their petals took on new shapes and brilliant colors, while their sweet perfumes attracted insects from far and wide. Nectar provided nourishment, while pollen gave insects a rich supply of food. In return, insects carried pollen from flower to flower, ensuring the plants could reproduce. This partnership between plants and insects grew closer with every passing generation. Flowers and their pollinators co-evolved, shaping each other into new forms of beauty and function. By the end of the Cretaceous, flowering plants had begun to dominate landscapes, spreading alongside ancient conifers, cycads, tree ferns, and broad-leaved trees like walnuts, beeches, and plane trees. Pollination could occur by wind or by rain carrying pollen to receptive ovules, but insects became the most reliable couriers. Dragonflies, beetles, cockroaches, and true bugs joined this intricate dance of survival. One fossil bee, known as Cretaceous, reveals how advanced this system already was. This tiny insect, buzzing among dinosaurs, carried special bristles on its legs designed to trap and hold pollen grains as it moved from bloom to bloom. It was a creature astonishingly similar to tropical bees still alive today. Amid this bustling world, mammals remained small and secretive. They were like shadows slipping through the cracks of a dinosaur-ruled reality. These primitive mammals were never given much space in the ecosystems of their time, for reptiles and dinosaurs dominated every available niche. To survive, mammals made the night their ally. When the great reptiles slept, mammals emerged from their burrows, hollows, and caves to hunt and forage. They had keen eyes adapted to dim light, sensitive ears that could catch the faintest sounds, and long whiskers that guided them in the dark. Their sense of smell was strong, helping them locate food and avoid danger. This nocturnal life demanded a larger brain to process the flood of information their senses gathered. A larger brain, in turn, demanded more energy. To meet these demands, mammals developed warm-blooded bodies and fur coats that kept their heat steady through the cold of night. They became hunters of insects, worms, seeds, and whatever else they could find. Their teeth grew sharper and more specialized, able to slice, grind, and crush. These tiny animals may have been overlooked in their day, but they carried within them the seeds of a future when they would rise after the giants had fallen. For all the richness and vitality of this world, it was destined to be shattered. Toward the end of the Cretaceous period, an event of unimaginable violence struck the Earth. A vast meteor, travelling faster than sound and glowing with the fury of space, plummeted toward the planet. When it hit, the force of its impact shook the entire globe, releasing more energy than all the volcanoes and earthquakes of the age combined. This impact marked the boundary between the Cretaceous and the Paleogene, and it is one of the most firmly established catastrophes in the history of Earth. The blast unleashed fire, shockwaves, and clouds of dust that would choke the skies, changing life forever. A giant asteroid, larger than the highest mountain on Earth, came hurtling through the blackness of space. It rushed forward at an unimaginable speed, nearly 65,000 kilometers every hour, which is about 40,000 miles in the same time. Its size was monstrous, measuring more than 10 kilometers across, or about 6 miles in width. Its weight was beyond comprehension, 1 billion tons of solid rock and metal tearing through the void. For millions of years, this piece of cosmic debris had wandered silently between the planets, but on this day its path led directly to Earth, and nothing could stop the collision. As it entered the atmosphere, the friction with the air heated it to blazing white, brighter than anything the creatures of the Earth had ever seen. The moment was swift, a flash of fire in the sky, and then it smashed into what is today the province of Yucatan near the Gulf of Mexico. The force of the impact was greater than the power of every volcano, every earthquake, and every storm in Earth's history combined. The energy released could not even be measured in ordinary terms. It was beyond the human mind's ability to fully grasp. The asteroid tore into the ground and carved out a colossal crater, 30 kilometers wide and nearly 20 kilometers deep. The violence of the strike was so immense that the very rocks of Earth's crust melted and became liquid for 60 kilometers in every direction, which is about 40 miles around the point of impact. Water from the nearby seas and rivers boiled away in an instant, turning into a massive cloud of steam that rose into the sky. Everything alive within this vast area perished instantly. Thousands upon thousands of animals were gone in the blink of an eye, destroyed so quickly that there was no time for fear or even pain. Their end came as silently as falling asleep, but for others further away the catastrophe was only beginning. They saw a flash brighter than the sun. Then, only moments later, a shockwave formed. It was a wall of vaporized rock and dust, hotter than any fire, moving outward across the ocean at incredible speed. The air itself ignited and everything around was seared by unbearable heat. Trees burst into flames, plants curled into ash, and most creatures caught in the open were vaporized or burned alive. Only those able to hide deep inside caves, burrows, or cracks in the earth had even a faint hope of survival. The impact unleashed such energy that fires broke out across entire regions. Flames rolled over the land, devouring forests, grasslands, and marshes alike. The world became smoke and fire. Dinosaurs, those mighty giants that had ruled the earth for millions of years, were too large and too slow to find safe shelter. Their massive bodies, which once made them kings of their environment, became a curse. They could not escape the storm of fire and rock that descended upon them. The shockwave continued to spread, pouring out its fury for about 10 minutes. In that short span of time, it annihilated everything in its path. Yet the entire surface of Earth was not struck at once. Some animals, far removed from the direct blast, had no idea what had just happened. But soon the consequences of this cosmic blow would reach them too, no matter how far they were from the Gulf of Mexico. The asteroid's collision set off a gigantic earthquake. The ground shuddered with a force no living creature had ever known. Cracks split open the surface of the earth, swallowing trees and animals whole. Landslides rumbled down mountains, shaking valleys into rubble. The earthquake did not stop at the point of impact, but travelled across the entire globe, rippling through continents and oceans alike. The tremors continued for days, aftershocks rocking the planet long after the first strike. But this was not the worst of it. Out at sea, the impact created a tsunami unlike any other in history. It was not a mere wave, but a mountain of water stretching across the horizon. It was as high as a mountain range and moved with a speed that defied imagination. It crossed the Atlantic Ocean at nearly 1,000 kilometers an hour, which is more than 600 miles every hour. The wall of water grew taller and taller as it neared the coasts, then crashed down with unstoppable force. Entire forests were torn from the soil, animals were swept away like twigs, and even the strongest rocks were reshaped. When the water retreated, it dragged back everything in its path. Trees, stones, corpses, and entire sections of land. The very shape of the continents was altered. New hills rose, new valleys sank, and fresh canyons were carved where once there had been plains. The sea finally calmed, but only for a moment, for the asteroid strike had sent millions upon millions of tons of rock hurtling into space. These pieces of earth, thrown upward like sparks from a fire, now began to rain back down. They fell for hours, from tiny fragments the size of peas to massive boulders as large as houses. They lit the skies as fireballs, and when they struck the ground, they raised temperatures even further. The very air grew hotter and hotter until entire regions of the earth burned. Forests that had not already caught fire now ignited. Millions of animals, unable to escape the heat, were roasted alive. In less than a single day, most of life on Earth had been destroyed. The heat became so intense that oxygen levels in the atmosphere rose, feeding the flames. The fires spread without end, a great burning that devoured nearly everything green. Amid the chaos of fire and ash, a handful of survivors struggled on. Some dinosaurs still roamed the apocalyptic wasteland, their huge bodies staggering through the smoke as they searched for food or water. But their rule was over. Among the ashes crept small creatures, easy to overlook yet destined to shape the future. One of them was Prehistoric, a tiny mammal that looked like a large mouse. For millions of years it had lived in the shadows, hunted by giant reptiles, never daring to step into the open. It survived by climbing trees, eating insects and fruits, hiding whenever danger approached. Now, as the dinosaurs perished, this humble creature suddenly had an advantage. Its small body could slip into burrows, its quick movements allowed it to climb to safety, and its flexible diet gave it the chance to eat whatever could still be found. It represented the early beginnings of a family that would one day lead to monkeys, apes, and eventually human beings. As the fires burned, clouds of ash and dust filled the sky. The impact had released sulfur in enormous amounts. This sulfur mixed with water in the air, creating sulfuric acid. Soon, deadly rains fell to Earth. The drops burned skin and flesh, scalding the survivors that had not managed to hide. Even the oceans were struck, their waters poisoned by the acid rain. The sky itself darkened. The thick ash clouds gathered, layer upon layer, until the sun could no longer pierce through. Day was turned to night, a night that did not end for weeks. Plankton in the seas, which depended on sunlight, began to die. With the plankton gone, the food chain in the oceans collapsed. On land, dinosaurs, which relied heavily on their sight, found themselves nearly blind in the endless gloom. Their strength was useless when they could not see where to hunt or where to flee. But the small mammals, already accustomed to creeping about at night to avoid predators, were at home in this strange world of darkness. They had developed nocturnal eyes and instincts, and now these traits became keys to survival. Plants too suffered. Many had already burned in the wildfires, but those that remained alive could not grow without light. The great herbivores, starved of food, grew weaker and weaker. Even the predators that fed on them began to starve. The balance of the old world crumbled piece by piece. After weeks of darkness came months of cold. Without sunlight, the earth grew icy. The lush, warm world that had once been filled with greenery turned into a frozen wasteland. The survivors had to endure biting winds and snow where once there had been forests. Prehistoric, like other small mammals, curled into its burrow to keep warm. It ate whatever scraps it could find: insects, seeds, fruits, anything edible at all. That desperate adaptability saved it, while the mighty dinosaurs, unable to find food and unable to adjust, slowly disappeared. In less than a single year, the planet had been emptied of most of its life. Nearly 3/4 of all species that had once lived on Earth were gone forever. The oceans became barren, with only a few kinds of fish and sharks managing to cling to existence. On land, the rule was clear. The smaller an animal was, the greater its chance of survival. The giants had fallen, while the overlooked survivors inherited the Earth. The collapse happened in stages. Some creatures died within minutes of the impact, others within hours as the shockwaves and fires spread, others still within days or weeks as darkness and starvation set in. Within months, the Earth's climate had shifted, and within a few years, the once mighty age of the dinosaurs was over. For nearly 200 million years they had dominated, and now they were gone. The world was left almost empty, a vast desert of ash and ice. Yet in this emptiness, the seeds of a new chapter were beginning to grow. For the tiny survivors that had managed to live through the worst, there was now opportunity. With no predators left to hunt them, they could breed freely. With no giant reptiles overshadowing them, they could spread into empty lands and empty skies. Slowly, quietly, patiently, these small survivors would repopulate the Earth, and in time their descendants would rise to become the new rulers of the planet. How did life on Earth find its way again after the cataclysm that struck down the mighty dinosaurs? The story of recovery is one of patience, chance, survival, and transformation. Today, many animals that disappeared long ago are better known to us than some creatures that are alive and moving around our planet right now. Among these long-gone beings, none have captured the imagination of humankind as deeply as the dinosaurs. Even a child who has never seen a real living crocodile or a rare bird can often name the Tyrannosaurus or the Diplodocus. The Diplodocus, a long-necked giant that once walked the ancient forests and plains, is more widely recognized than many animals that still walk the earth today. The Tyrannosaurus, with its fierce jaws and towering presence, is more famous than creatures such as the Paramilodon or the Ava, names that sound almost strange to our ears, though they once represented real beings that struggled to live in their own time. Dinosaurs have become woven into stories, movies, books, games, and the minds of countless people. They are no longer just ancient animals, they are part of human culture, myth, and identity. But before they became fossils and legends, dinosaurs were living masters of the Earth. For more than 165 million years, which is a span of time far beyond what most human minds can fully imagine, they reigned over land, air, and even water. They filled almost every possible ecological role. Some were as small as chickens and darted through undergrowth, while others were taller than houses and stretched longer than trains, slowly moving across the landscape in herds. There were hunters with teeth sharp enough to crush bone, and there were gentle giants who swept entire forests with their long necks to feed on leaves. Dinosaurs were not just animals, they were rulers of an age. They left little space for others to rise to greatness. Mammals, which already existed in those times, were tiny, nocturnal, and mostly forced to remain in the shadows, surviving quietly while the enormous reptiles thundered across the world above them. The Earth, however, is not a place of eternal stability. Across its long history, stretching billions of years, our planet has suffered at least 5 times what scientists call mass extinctions. These are moments when life itself has been tested, when a huge part of all living species suddenly vanish. The causes have been different in each case: volcanic fire, shifting continents, sudden changes in the chemistry of the oceans, or great impacts from outer space. But each time, life has been forced to begin anew, reshaping itself and exploring fresh paths of evolution. These upheavals have left permanent marks on the story of the Earth. The last of these great disasters came about 66 million years ago. It was the 5th such crisis, and it ended the time of the non-avian dinosaurs. The details of this catastrophe are now widely known. A rock from space, several kilometers wide, crashed into what is now the Yucatan Peninsula in Mexico. The explosion released energy more powerful than countless nuclear bombs. Fires swept across forests, a cloud of dust and ash spread through the skies, sunlight dimmed, plants withered, and the chains of life that depended on them collapsed. Ocean creatures also suffered as the seas grew acidic and food chains collapsed. In the end, about 3/4 of all living species disappeared. Among them were the great dinosaurs that had dominated the Earth for so long. Only their smaller bird-like relatives, which we now call birds, managed to make it through and continue the dinosaur story in a new form. The disappearance of the dinosaurs left an emptiness like no other. For the first time in more than 165 million years, the Earth was without its giant rulers. This was a loss beyond measure. It was as if the stage of life had been cleared in one sweeping gesture, leaving only broken pieces and scattered survivors. But nature has a way of turning even loss into opportunity. One creature's downfall became another creature's chance. The world was open once again, its niches unguarded, its possibilities waiting to be filled. It was in this silence, in this world without the heavy footsteps of dinosaurs, that mammals began their rise. Before the extinction, mammals had been small, secretive, and often nocturnal. They lived in burrows, in shadows, or under the cover of night, eating insects, seeds, and sometimes the eggs of larger creatures. They had never been able to grow very large or to expand into many different forms because dinosaurs had already taken those places. But now the stage was empty, and the mammals began to grow bolder. Within a few million years, a short time by geological standards, they started to explore new sizes, shapes, and ways of life. Some grew larger to graze on plants, others became hunters, and many developed unique skills of intelligence, dexterity, and adaptability. Birds also seized this chance. The ones that survived the disaster slowly spread into many forms, from waterfowl to raptors to songbirds. They filled the skies once more, taking over the ecological roles once held by pterosaurs, the flying reptiles that had also disappeared. The world was being reshaped, slowly and steadily, by survivors who were now becoming pioneers. The recovery of life after the extinction was not fast. In human terms, it feels almost impossibly slow. It took hundreds of thousands of years for plants to recover fully, millions of years for animal life to regain its diversity, and tens of millions of years for new ecosystems as rich as those of the dinosaurs to appear. But from that long process of recovery came the familiar world we know today. The forests, the mammals, the birds, and eventually the primates. All of them are children of that catastrophe. Without that sudden end of the dinosaurs, the Earth might still be ruled by reptilian giants. The mammals that gave rise to us might have remained small, timid, and hidden. Birds might never have taken such a central role in the skies. Evolution might have taken a completely different path, one in which humans never appeared. In a strange way, our very existence is tied to that moment of destruction 66 million years ago. The loss of the dinosaurs was the beginning of our story. The tale of a life's recovery after the dinosaurs is also a reminder of how fragile, and yet how resilient life can be. Species may vanish, entire groups may disappear forever, and yet life as a whole finds ways to adapt, to rise again, and to reshape the Earth. The extinction that ended the dinosaurs did not end life. It merely changed its direction, and from that change came the world we live in today. The age of the great reptiles comes to a sudden and violent close. Those towering beasts that had ruled land, sea, and sky for millions upon millions of years are swept from existence in a moment of catastrophic change. Where once their heavy steps shook the earth, silence falls. Yet, life, though shaken, does not end. Some groups survive, though only as shadows of what they once were. From the ashes of destruction, the story of survival, renewal and transformation slowly begins to unfold. Among the reptiles, only 4 great lineages cling to existence. The turtles, armoured wanderers with their shells, crawl onward into the new age. The crocodiles, descendants of ancient river hunters, remain lurking in swamps and rivers. The snakes, those silent, slithering predators, survive in their coils, and the lizards, agile and adaptable, carry on as well. All the other branches vanish, leaving these few to inherit a broken world. The seas, once teeming with brilliant colonies of coral, turn into graveyards. Almost all of the corals that built vast, colourful underwater cities in the warm tropical shallows perish. 98% of these colonial species disappear, their delicate skeletons bleaching and crumbling away. Only the solitary kinds of corals, the ones that chose colder and deeper waters where light was scarce, manage to endure. They hold on stubbornly, their lonely towers standing where great reefs once stretched for miles. Other sea creatures fare no better. The echinoderms with their spiny skins and the bivalves with their double shells lose many of their kinds. Whole genera vanish from the records of life. The cephalopods, masters of the ocean, suffer a devastating blow. Ammonites, those coiled and chambered beauties that had thrived for millions of years, vanish forever, along with the swift and darting belemnites. They sink into the dark waters of extinction. The only cephalopods to weather the storm are the nautiloids, represented today by the mysterious nautilus, and another hardy group that will one day give us the octopuses, the squids, and the cuttlefish. These survivors cling to life while their cousins vanish like fading stars. The disaster strikes the very foundation of the food chain. Without sunlight, plants shrivel and collapse. Great forests that once fed herds of plant-eaters fall silent. Without green life to eat, the huge herbivores waste away, their bellies empty, their bones scattered. The same tragedy plays out in the oceans. The plankton, the tiny drifting specks that are the sea's invisible harvest, vanish, and with them go the countless creatures that depended on them. Small fish, delicate filter feeders, and eventually the larger predators that fed upon those. The oceans grow quiet and empty. hunger echoing through every layer of the waters. Yet even in this bleakness, some life endures. Small creatures that feed on scraps, the debris eaters, cling stubbornly to survival. These humble scavengers, used to digging through mud for rotting plants and tiny animals, manage to endure even when everything around them perishes. In rivers and lakes, they burrow into the mud and slow their lives to a near standstill. Time drifts around them while they wait in silence, able to survive both cold and drought. On land, the same kind of small feeders scrape together meals from seeds, fallen leaves, and even corpses. Their ability to hibernate, to sleep through the worst, gives them a strength that giants lack. They are small, but they are hardy, and that makes all the difference. Another kind of survivor carries a gift that proves decisive, the ability to keep their bodies warm. Mammals and birds are not ruled by the whims of the outside air as reptiles are. Their warm blood, their constant inner fires, allow them to carry on even when the world turns cold. This independence from the frozen climate lets them outlast many of the creatures that once overshadowed them. Those that live by the coasts and seas also find themselves better placed to endure, sheltered by the abundance of life the shifting waters still provide. Whether it is luck or some hidden strength of adaptation, they make it through when others fall. The truth is stark. No creature can truly adapt to a catastrophe of this scale in the moment. Natural selection is a slow sculptor, working patiently over ages, but this extinction is sudden, violent, and merciless. Species die not because they are weak, but because chance and circumstance strike them down. Still, those that remain do so because by accident or hidden resilience, they are better suited to the strange new world that follows. In the aftermath, the Earth changes. At first it warms, but then a long cooling begins. Tectonic plates shift and groan, lifting mountains skyward and altering the courses of mighty ocean currents. As these mountains rise, they drink in carbon dioxide from the air, pushing the climate into colder patterns. The world, once warm and lush, begins to grow chillier. But this is not the end of upheaval. Barely 10 million years after the Great Extinction, a wound opens in the northern continents. From this tearing land, immense amounts of carbon dioxide pour into the air and into the seas. The temperature of the Earth leaps upward by at least 5 degrees Celsius. Ecosystems already fragile are thrown into turmoil once again. The forests thicken and grow dense, reshaping the land. The very course of evolution bends beneath this warming. Mammals in particular feel its force, and their story begins to twist in new directions. The last remnant of the ancient supercontinent Gondwana at last breaks apart. Australia drifts away, carrying with it an extraordinary collection of plants and animals. Isolated from the rest of the world, its living treasures take a unique path, giving rise to wonders that still exist today in kangaroos, koalas, and strange egg-laying mammals. Antarctica, drifting into its place at the pole, is encircled by a cold current that locks it away from warmer waters. Its fate is sealed, and ice spreads across its surface, turning it into the frozen land we know. Now the world belongs to new rulers. Flowering plants spread widely, painting the earth with colour. Songbirds fill the air with music, their voices rising in a world that no longer echoes with the roars of dinosaurs. Mammals, once timid and small, begin to flourish. In the oceans, mammals rise too. Vast whales gliding through the waters, seals basking on coasts, and countless species of modern fish swimming in endless schools. Sharks, ancient hunters, continue their reign in the deep, unchanged and unchallenged. Life bursts forth in 1,000 shapes, filling the empty spaces left behind, building the foundations of the living world we now know. Yet the giants are gone. No longer do the largest of reptiles dominate the land. The survivors are modest, small snakes, quick lizards, smaller crocodiles, and sturdy turtles. It is the birds that rise to become the new giants, taking the mantle of size and power. Among them are creatures of astonishing form. The Gastornis, also known as deer trimmer, strides across forests and swamps. Standing nearly 2 meters tall, with a heavy beak like a hammer and strong legs built for running, it is a fearsome sight. Though it cannot fly, its presence commands the landscape much like the ostriches of today. In its tropical world, it has little to fear. The mammals and crocodiles of the time are smaller, no threat to its towering bulk. Its thick beak crushes seeds and bones alike, and its claws make it as capable a predator as it is a forager. Even more astonishing is the terror bird, the titan of the skies, though unlike Gastornis it does take to the air. Its wings stretch 5 meters wide, the largest of its age, with each wing covering more than 17 square meters. With strong legs and talons that grip like steel, it swoops upon prey with terrifying precision. It can lift and crush smaller mammals, hunting with the mastery of an eagle the size of a small plane. These monstrous birds rule the open plains and sparse savannas, chasing down early horses and scavenging from carcasses, playing the role of predators and vultures alike. For a time, these avian titans dominate, unchallenged at the top of the food chain. Mammals are still too small to oppose them, and reptiles have dwindled. In this strange in-between age, birds hold the crown. Their shadows stretch across the earth, haunting forests, swamps, and plains. But the reign of giants, whether reptilian or avian, is always fleeting. Over time, the enormous birds give way to smaller, more adaptable kinds. Yet in their moment, they stand as reminders that the fall of one age always gives birth to another, and that even after the greatest of catastrophes, life finds a way to rise, transform, and flourish anew. The world after the age of the great reptiles was a place of constant change and discovery, a place where new animals were trying out different shapes, sizes, and ways of life. Among the most successful of these early explorers of life's possibilities were the strange group known as the Prehistorics. From this group would one day come some of the most familiar and beloved animals we know today: the horse with its long legs and flowing mane, the tapir with its short trunk and shy habits, and the rhinoceros with its heavy body and powerful horn. In those ancient times, however, the story was only beginning, and the 3 great lineages of horse, tapir, and rhinoceros were still joined together, so close in appearance that it was difficult to tell them apart. The animals of that family had not yet scattered into the very different shapes and lifestyles we see in our own age. Instead, they were like brothers of the same household, sharing many of the same features, yet already moving in different directions. Even though their bodies were alike, the way they lived and the places they chose to inhabit were not the same. Some grazed in open areas, some searched among the leaves of the forest, and some took to different plants altogether. This separation of diet and living space was not just chance. It was the silent hand of survival guiding them, for if too many of them had competed directly for the same food, then some of them would surely have vanished forever. Nature has its own laws, and one of them is that too much rivalry often ends with the disappearance of the weaker. By choosing different foods and different ways of life, these early Prehistorics avoided that fate and allowed their 3 branches to grow stronger in their own directions. Among these early creatures was one small animal that carried the future of the horse hidden within its bones, although no one looking at it then would ever have guessed. This was the Hyotherium, a name given by later scientists, but in truth it was no larger than a small dog. It measured only about 60 centimeters from nose to tail, not more than 20 centimeters tall at the shoulder, with a light body that could easily slip through the undergrowth. In inches, that meant about 20 in length, and not much more than 8 in height. A truly tiny ancestor for an animal that would one day gallop across the wide plains of the earth. Its feet were not yet the hooves that thunder in herds today, but soft padded paws, much like those of a dog, each with 4 toes on the front feet and 3 toes on the back. The modern horse stands on a single hoof, like a runner balanced on tiptoe, but this little ancestor walked more flat-footed, spreading its weight over several toes. Its mouth held around 40 teeth, not sharp ones for tearing flesh, but flat ones built for crushing soft leaves, young shoots, and tender plants. It was a herbivore through and through, one of the countless eaters of green things that shaped the landscape by the pressure of their appetite. Yet life was not easy for this tiny horse of long ago. Dangerous birds prowled the land, some taller than a man, with beaks strong enough to kill and claws that could tear. Again and again, the little Hyotherium must have fled from these wingless hunters, darting for cover beneath the trees, relying on speed and agility to escape death. While the ancestors of horses were creeping along the forest floor, far away in North America, another branch of the Prehistoric family was experimenting with a different shape. This was Hepton, a primitive tapir, about 1 meter long from head to tail, which is to say the size of a small pig. It had a skull and limbs that would remind us of the tapirs that still wander the jungles of South America and Southeast Asia today. But unlike them, Hepton did not yet carry the short trunk, the curious little flexible nose that modern tapirs use to pluck leaves and fruits. It was a simpler creature, a beginner in the line that would one day lead to the modern tapir family. Close to Hepton in both time and form was another cousin, Hyarseus, one of the earliest rhinoceroses. It was slightly larger than Hepton, heavier of bone and stronger of frame, but it did not yet bear the horn that would later become the proud mark of its kind. No warrior's weapon rose from its nose, only the plain face of an ordinary animal. Yet the hornless Hyarseus still carried within it the promise of the mighty rhinoceroses to come. Alongside them were others such as Horatius and Hither, all so similar in those early days that one could easily mistake one for the other. It was only later, through millions upon millions of years of slow change, that their family lines began to separate and their differences became clear. While these primitive hoofed animals were spreading and adapting, new mammals of other forms were also appearing, filling the earth with fresh possibilities. One of them was Phoenicetus, a medium-sized herbivore that bore a vague resemblance to both a deer and a horse, though it was neither. It stood at the root of an entirely new branch of the family tree. Its body reached up to 1.5 meters in length, its legs were long and straight, and its face ended in a narrow snout. Each of its 4 limbs ended not in hooves but in 5 full fingers, making a total of 20 claws, which it used to walk somewhat like a tapir of today. Later, through long ages, those fingers would be transformed into the hooves that are now the mark of many grazing animals. Phoenicetus had teeth suited not for soft leaves but for harder vegetation, the tough plants of its environment. It represented a bold step in adaptation, for the world itself was changing. Forests still covered much of the earth, but grasslands were beginning to spread, and with them came new challenges and new diets. Herbivorous animals were forced to experiment, to try new ways of feeding, and Phoenicetus was one of the pioneers of this great transformation. Life's variety in those days was far different from what we know now. The families of mammals were constantly evolving into new shapes and new lifestyles. Some became swift runners, stretching their legs for speed. Some took to the air as gliders and true flyers, the bats whose wings would one day fill the night skies. Some entered the waters as swimmers, learning to move with ease in rivers and seas. Some became jumpers with springing legs, some diggers burrowing beneath the earth. There seemed no limit to the directions in which they could go. From blazing deserts to frozen poles, from treetops high above the ground to the depths of swamps, mountains and oceans, they spread across every environment the planet offered. Nature rewarded innovation, and those with special gifts often thrived. The wings of bats, the large incisors of rodents, these were not just oddities but crucial keys to survival and success. Among the many strange creatures of this time was Brontotherium, a massive ungulate whose name means thunder beast. It looked somewhat like a rhinoceros but was far larger, rivaling even elephants in size. Its body stretched up to 5 meters in length and could weigh as much as 5 tons. On its snout it carried a pair of horns, males bearing larger and more imposing ones than the females. Despite its fearsome appearance, Brontotherium was no hunter. It was a plant eater, feeding mainly on tender leaves and shoots, stripping the trees and bushes of their greenery. One can imagine the thunderous sound of a herd of these colossal animals moving through the forest, branches breaking beneath their weight, the ground shaking under their feet. Alongside these giants lived Paracodon, a much smaller creature but still impressive in its own way. It was only about 1.5 meters long, 80 centimeters high, and weighed around 100 kilograms, the size of a sturdy pony. Paracodon was in fact one of the early rhinoceroses, though it carried no horn upon its face. Instead, it was a runner, built for speed, roaming the steppes and open forests in search of food. It fed on a wide variety of vegetation, its diet broad and flexible. Its body was light compared to its head, which looked disproportionately large. Its legs were slim, ending in 3 toes, a form that gave it both balance and swiftness. But where there are grazers and browsers, there must also be hunters, and the world of that time was no different. Carnivorous mammals were diversifying just as quickly as their prey. Among them was one of the most fearsome of all, Hyenodon, whose name meant hyena-toothed. At first glance, Hyaenodon might have been mistaken for a big cat, with its powerful body, long tail and sharp claws at the end of each toe. Its jaws were massive, filled with teeth like knives. Though its brain was not large, its senses were keen, especially its sense of smell, and its strength and speed made it a deadly predator. Hyaenodon could reach 1.5 meters tall at the shoulder, and as much as 3 meters from nose to tail, a formidable size. It could run at speeds of 55 kilometers per hour, fast enough to chase down many kinds of prey. It was both a hunter and a scavenger, killing when it could, but also feeding on the remains of the dead. Cleverly, when it found a carcass, it often covered it with excrement, hiding the smell so that other scavengers would not discover it. Its life was one of tooth and claw, and it feared little, not even the great terror birds like Gastronus that roamed the land. When Hyaenodon attacked, it relied on its sharp teeth to crush bones and flesh alike. To the animals of that age, it was a creature of nightmares. As all of these dramas unfolded, time itself moved onward, silent and unstoppable. Around 55 million years ago, a group of mammals took a very different path in their journey through evolution. Equipped with 2 eyes set close together on the front of their faces, and with hands carrying thumbs that could move against the other fingers, the earliest primates entered the stage of life on Earth. These creatures were very different from the giant reptiles that had once ruled the world. They were small, fast, and clever, and their future line would eventually lead to beings as varied as tiny marmosets, great gorillas, and even human beings. Their story began long ago with their forerunners, the Plesiadapiforms, small mammals that lived in trees and fed mainly on insects. These little animals were quick and nervous, always alert, and they had survived one of the darkest moments in the planet's history. Among them was a tiny creature known as Purgatorius, which appeared right after the colossal meteorite struck the Earth about 66 million years ago, bringing the reign of the dinosaurs to an end. Purgatorius, so small it could hide among fallen leaves and twigs, crept through the undergrowth, surviving in a world where so many larger animals had perished. From these fragile beginnings, the Plesiadapiforms began to spread and diversify. Over millions of years, they gave rise to more than 100 species scattered throughout tropical forests across the globe. They were no bigger than hamsters or squirrels, scurrying among the branches, feeding on insects, fruits, and tender shoots. Yet, despite their success, these animals were still not considered true primates. Their skulls had a primitive structure, their brains were small, and their feet and hands still carried sharp claws instead of the softer, flatter nails that would later appear in true primates. They were agile but limited, lacking the refined grip and the forward-looking eyes that would allow future generations to master the 3-dimensional world of the treetops. The first known creature that could truly be called a primate was named Altiotlasius. This small animal lived around 55 million years ago, and from it, whole lineages spread across the northern hemisphere, populating forests in Europe, North America, and Asia. At that time, primates became one of the most diverse groups of mammals on Earth. The evolution of their bodies changed the way they lived. Their legs and arms slowly adapted into more flexible hands and feet. The sharp claws that had once been their main tools began to flatten into nails, giving them a gentler, more precise way of grasping. Their thumbs became opposable, able to move against the other fingers, which meant they could hold branches firmly and manipulate food with care. Their faces also began to change. The eyes moved forward, closer together, giving up the wide-side vision that many other animals still relied on to detect predators. This meant they could no longer see all around them at once, but instead they gained binocular vision, the ability to judge depth and distance with great accuracy. This was vital for life in the trees, where a misstep could mean a fatal fall. With their new vision, these early primates could leap from branch to branch, measuring the space with precision, landing safely where earlier creatures would have slipped. The tops of their skulls also reshaped, making more room for growing brains, which would help them develop new behaviours and greater intelligence. By 45 million years ago in the lush forests of Asia, the first true monkeys began to appear. Unlike their insect-hunting ancestors, these new primates were often omnivorous or vegetarian, feeding on fruits, leaves, and sometimes small animals. Their brains were larger, and with this came more complicated social lives. They lived in groups, communicated and cooperated, forming bonds that would become one of the hallmarks of primate evolution. In the swampy forests where mist hung between the trees and countless plants grew thickly, primitive monkeys lived side by side with their smaller, more ancient cousins, the prosimians. One of the earliest apes was Catapithecus, which lived around 36 million years ago. Small and agile, it showed features that set it apart from earlier primates. But among the best known of these ancient apes was Egyptopithecus, an animal that lived in the rainforest that covered parts of North Africa about 30 million years ago. Egyptopithecus weighed around 6 to 7 kilograms, similar to a modern howler monkey of South America. It climbed trees, moved carefully along branches, and fed mostly on fruit. It already carried many of the features that distinguish monkeys and apes, called simians, from their more primitive relatives, the prosimians. Egyptopithecus had a larger brain than its ancestors. Its eye sockets were completely enclosed by bone, protecting the eyes from the brain cavity beside them. Its eyes were closer together, improving binocular vision, but at the cost of reducing its sense of smell. Its jaw was strong, armed with molars that had flat crowns, perfect for grinding fruit and leaves. These changes showed that vision and intelligence were beginning to matter more than smell and instinct. From these ancient forms, primates branched out into many different species, each carrying the same basic design but with unique features suited to their environments. Their limbs always carried 5 fingers with nails instead of claws. Their hands, perfected with opposable thumbs, became sensitive tools for gripping, holding and touching. Their eyes faced forward, their vision sharpening as their noses grew less important. Their social worlds grew more complex. Mothers cared for their young for longer periods. Sexual maturity came later, and lifespans grew longer. Many species lived in groups, sometimes only a few individuals, sometimes hundreds, moving through forests together, finding safety in numbers. The way primates reproduced was also different from many other mammals. Females usually gave birth to a single infant, occasionally twins, and they invested immense energy and time in raising them. This slow, careful style of life meant that each child had a better chance of survival, learning from its mother and from the group around it. Primates varied widely in size, from tiny creatures weighing only 50 grams to great apes weighing over 100 kilograms. Their diets also shifted with size. The smaller primates were more likely to feed on insects or fruits, while the larger ones could handle a wider range of foods, often becoming omnivorous. They thrived in tropical and subtropical regions where the forests provided endless food and shelter. Most monkeys were active during the day, while many prosimians preferred the night, creeping among branches under the cover of darkness. Their movements were as varied as their diets. In trees, some carefully walked along branches, while others climbed or swung. On the ground, many moved on all fours, though they could sometimes rise up and run short distances on 2 legs. Some species grew long, flexible tails they used like a 5th limb, wrapping them around branches to hang or balance. The great apes developed a unique way of moving called knuckle walking, placing their weight on the second joints of their fingers. Though all primates could sometimes stand and walk on 2 legs, only humans would later make this their main way of moving. The decision to live in the treetops opened up new worlds for early primates. Above the ground, there was an endless supply of food in the form of leaves, fruits and flowers. There was also greater safety from many predators that hunted below, but the treetops also carried dangers of their own, for the 3-dimensional world was much more complex than the flat ground. One wrong move could mean a deadly fall. To survive, primates developed sharper vision, bigger brains, and more flexible bodies. They began to see the world in colour, an ability that helped them pick ripe fruits and fresh young leaves from among the green canopy. Among these early animals was Carpolestes, a small mammal about the size of a hamster, with teeth like those of rodents. Its long fingers and opposable thumbs allowed it to climb up to the very tops of trees with ease, yet its elbows were still stiff, making it unable to leap gracefully from branch to branch. Its eyes were placed more to the sides of its head, which limited its ability to judge distances, showing it was not yet a true primate, only a close cousin. In the same forests lived other remarkable creatures. One of them was Coryphodon, a large plant-eating mammal that spent its life in swampy areas, feeding on aquatic plants much like a modern hippopotamus. It was about the size of a wild boar and could weigh as much as 500 kilograms. Though its tusks were small, its bulk made it one of the largest animals of its time, towering over the tiny primates that scurried among the branches. And elsewhere, far from the forests, some four-legged land mammals were slowly evolving into something no one could have predicted. The ancestors of whales and dolphins, creatures that once galloped on land before they returned to the sea forever. The creature called Basilosaurus carries a name that means king of reptiles, but in truth it is not a reptile at all. It belongs to the group of mammals, and not only that, it belongs to the family of whales. At first glance, its body might trick the eye into thinking of a giant reptile or even a sea serpent, for it is long and sinuous, stretching out like a monstrous ribbon of flesh in the water. But when looked at more carefully, it shows the traits of a mammal, warm-blooded and alive in ways reptiles are not. Basilosaurus is enormous, its length greater than that of many boats, and its jaw, stretched like the blade of a sword, is filled with sharp teeth designed to tear into the bodies of fish, crabs, and mollusks. Unlike modern whales, which breathe through blowholes set high on their heads, Basilosaurus still carries its nostrils halfway along the snout, not yet shifted by evolution to the crown of the skull. This means it cannot simply raise a portion of its head above the surface for air. Instead, it must heave its whole snout out of the water to breathe, lifting the massive head like a breaching beast each time the lungs demand air. Its body tells a story of change written by time. On its sides, hidden low and small, are a pair of tiny hind legs, so little they are useless for walking or even for true swimming. These shrunken legs are leftovers from its land-dwelling ancestors, echoes of an age when their forebears still walked upon the earth. The legs serve no purpose now, except to remind the curious eye of the land creatures from which Basilosaurus descended. Its tail is long and strong, built like a whip of muscle and bone, and its front limbs are no longer arms, but have taken the shape of fins, stretched broad and flat to cut through the waters. With the tail and these powerful fin-shaped arms, Basilosaurus propels itself forward, gliding through coastal seas like a predator from a nightmare. Basilosaurus is not alone in its kind, for it is part of a greater story, the story of whales slowly leaving the land behind and claiming the sea as their new kingdom. The pull of evolution has pushed them step by step, or rather stroke by stroke, to adapt fully to the marine world. Those little hind legs, once strong enough to walk the earth, shrink more and more as the ages pass, until they become nearly invisible. The arms, which once ended in hands with fingers, transform completely into flippers built for swimming. The tail grows into a mighty paddle to thrust the body forward. Even the head changes, with the nostrils climbing slowly from the snout up to the top of the skull, until they become the blowholes that modern whales use to breathe. The inner ear too, once made for the air of the land, begins to change. It reshapes itself to sense vibrations not in air, but in water, allowing the animal to hear and navigate in the vast underwater world. Each small change is another step in a long migration, a journey not across continents, but across elements, from the soil and air to the endless sea. Long before Basilosaurus claimed its place in the water, there was Protocetus, an early kind of whale still clinging partly to the land. Protocetus is much smaller, no longer than 2.5 meters, or about 8 feet from nose to tail. Though it spends much of its time in the water, it still has legs, small and weak, yet strong enough that it can haul itself onto beaches or muddy banks. These legs are shaped like flippers, wide and flat, helping it swim, but also able to carry it clumsily across the ground when it must return to land. The mouth of Protocetus stretches long, armed with sharp teeth like rows of knives, perfectly made for catching slippery fish. Its ears already show signs of adapting to the sea, shaped so that it can hear sounds under the water, though not yet capable of the miraculous echolocation that its descendants will one day master. Its nostrils rest midway on the snout, neither at the tip like a land creature's nor at the crown like a modern whale's. This halfway position is like a marker in the journey, showing clearly that evolution is in the middle of its work. For Protocetus, life is still divided between the sea and the land. The females, for example, cannot yet give birth in the water as later whales will. Instead, they still crawl back onto the shore to bring forth their young, their bodies remembering the way of their ancestors. These creatures live in two worlds at once, belonging fully to neither, but preparing the way for the mighty whales that will one day roam the oceans. In the skies, another story is unfolding. Around the same time that whales are mastering the water, the first bats are beginning to master the air. Among them is a creature called a Cretaceous, one of the oldest known bats. Its body already looks strikingly similar to the bats of today. It wears a coat of fur to keep it warm, for even as a flyer it is still a mammal. From its arms stretch thin wings of skin, delicate yet strong, capable of carrying it across the night sky. The span of its wings can reach up to 35 centimeters, about 14 inches, wide enough to make it a graceful flyer. It has a long tail which it uses like a rudder, steering itself in sharp turns to chase after insects. Yet not all of its body is yet like modern bats. Its legs are still too small and weak to hang upside down as bats do today in their caves and trees. But even so, Cretaceous can already flap its wings to rise and fall through the air, hunting insects in warm climates where life is abundant. Close to the bats in their way of life are the Dimoptera, also called flying lemurs, though they are not true lemurs at all. These creatures are not flyers like bats, for they cannot beat their wings, but they are masters of gliding. Living high in the trees, they leap from branch to branch with astonishing skill. When they throw themselves into the air, they stretch out all four of their limbs, both arms and both legs, spreading wide the sail of skin that stretches between their wrists, ankles, and tail. This great sheet of skin, like a living parachute, catches the air and lets them glide silently from tree to tree. With this, they can travel more than 100 meters, which is more than 300 feet, without ever touching the ground. In the dense forests, such gliding is a powerful gift, allowing them to escape predators, chase food, or simply move swiftly through their leafy world. While these animals explore new ways of moving, some in the sea, some in the sky, some in the trees, the world of plants is also changing. Palms rise with their tall, feathery leaves, flowering trees burst into colour, and conifers spread their needle-like greenery. Yet the greatest change comes with the arrival of a new group of plants, the herbaceous flowering plants. These are plants with soft green stems instead of woody trunks, and they will soon conquer the world. Their success is tied to a partnership with animals. Insects, evolving as pollinators, carry the yellow dust of pollen from flower to flower, ensuring that seeds will form. Birds and bats join in, feeding on nectar, seeds, and fruit, and in return spreading those very seeds across great distances. The plants, in turn, give food and shelter to the animals, creating a cycle of life that thrives on cooperation. Herbaceous plants hold a secret advantage. When animals bite or cut away their leaves, these plants do not die. They grow back, stronger than before, continuing their life as if nothing had happened. Even when they are grazed down to the ground, they can sprout again. This resilience allows them to survive in open plains where herds of hungry animals roam. As they spread, the world begins to see the rise of vast grasslands, rolling fields of green that stretch as far as the eye can see. These grasses, belonging to the great group of angiosperms, become the foundation of whole new ecosystems. They grow in every kind of environment: lush rainforests, dry deserts, cold mountains, warm tropics, feeding countless animals with their seeds and leaves. From grasses come cereals, the plants that will one day feed humanity, though in this time they feed herds of ancient mammals and birds. Each grass flower is small and modest, but inside it hides the organs of reproduction, male and female together. Once the flower is fertilized, it becomes a fruit, enclosing the seed. These fruits are carried by animals, blown by winds, or washed away by water, spreading the grasses across the lands of Earth. Long before the continents of Gondwana fully separate, these plants have already found their way across the world. Among the animals that thrive in these grassy and wooded lands are the birds, the feathered heirs of ancient predators. Birds are small when compared to the massive reptiles of earlier ages, yet their survival is no accident. Their ancestors were hunters of the Jurassic period, fierce little dinosaurs with sharp claws and teeth. They did not fly then. Flight was not yet theirs. But slowly, through countless generations, feathers began to appear, first as simple filaments that served only to keep the body warm, then later as more complex structures. Over time, feathers were reshaped by evolution, first for insulation, then for display, for camouflage, for signaling to others, and finally for flight. The earliest bird-like creature known is Archaeopteryx, which appeared at the very end of the Jurassic period, about 150 million years ago. Archaeopteryx is a strange mixture of reptile and bird, its body and teeth reptilian, yet its wings clothed in feathers. It is a bridge between two worlds, linking the mighty dinosaurs with the birds that will one day sing in the trees. It likely descended from small, hollow-tailed dinosaurs, the coelurosaurs, which included both tiny nimble hunters like Compsognathus and giants like Tyrannosaurus. Some of these dinosaurs, covered in feathers, already had the ability to glide or fly. Their skeletons are almost identical to those of birds today, showing how close the connection truly is. The first feathers were unlike the neat veins of modern birds. They were messy, like tufts of down, branching loosely from a central point. Later they became more structured, forming the strong veins we know. Some birds, like the kiwi of New Zealand, still carry feathers that resemble hair, soft and simple, showing how feathers can take many forms depending on need. Feathers serve many purposes beyond flight. They insulate the body, keeping warmth trapped close to the skin. They shade eggs from the burning sun, or keep them warm in the cold. They dazzle the eye during courtship displays, signaling health and strength to a mate. They hide the body in camouflage, or mark individuals so that they can recognize one another. They are armor, they are clothing, they are banners for show. Only much later did they become wings. To fly, an animal must do more than grow feathers. Its body must change entirely. The bones must grow hollow to be light. The sternum, or breastbone, must grow large and strong to anchor the powerful muscles of the wings. The feet must change so that they can perch. The lungs and metabolism must become so efficient that they can produce energy quickly enough to keep the animal aloft. The wings themselves must be shaped to generate lift, creating a wake of air that pushes the animal forward. The brain and nerves must coordinate with perfect timing, adjusting every beat of the wing. With all of these changes together, flight becomes possible. It is one of the hardest and most beautiful tricks evolution has ever achieved. Archaeopteryx, that strange animal which lived long ago, already carried within its body the tools of the sky. Its wings were not simply arms with feathers attached, but real wings capable of performing the complex movement needed for flight. When it stretched them out, it could create the powerful stroke that is the very heart of flight, pushing air downward and lifting the body upward. In its skull lay an ear canal shaped in such a way that it betrayed a special talent. It showed that this creature could sense and navigate space in 3 full dimensions, an ability that was especially useful for an animal that no longer moved only across the flat ground, but also through the open air. Yet even with such gifts, it seems that Archaeopteryx was not a master of the skies. Its wings may have carried it into the air, but only with effort, perhaps only for short bursts, or perhaps only when leaping from a height. Its flight looked fragile compared to the powerful wing beats of the birds that would come millions of years later. There are many ways to imagine how such a remarkable ability could have begun. One story tells of trees and the creatures that climbed them. Perhaps some of these small feathered animals scrambled up into the higher branches, escaping predators or reaching insects and fruits. From those branches they might have leapt into the void, first falling, then gliding, then fluttering. Each generation would carry feathers shaped a little better, wings stretched a little wider, until at last the leap became not just a fall, but a flight. Another story paints a different picture. It places these feathered animals not in trees but on the ground, racing across open spaces, their legs pounding the earth. As they ran, their arms, covered in feathers, flapped wildly. At first this may have given only balance, helping them turn or steady themselves. But with time, these frantic flaps may have generated real lift. Their bodies, lighter and lighter over generations, their feathers broader, their bones hollow, finally lifted into the air. Whether from branch to branch or from the ground up, the dream of flying had begun. Birds, from that moment, carried the destiny of the skies within their bones. Though fragile and sensitive to the slightest change in the environment, they alone would carry forward the legacy of the dinosaurs. Today, more than 10,000 species of birds are alive across the Earth. In contrast, during the Great Age of Dinosaurs, there were only a few lines of such flying creatures. The Archaeopteryx line was among them, as well as the terrible and magnificent pterosaurs, who were not birds but close neighbours in the sky. From those few beginnings, a grand unfolding would occur. By about 55 million years ago, most of the main orders of birds that still live today had already been established. Their wings, their songs, their hunting styles, their ways of raising young, these were already being shaped into the forms we now know. This flowering of diversity was pushed onward by a world that was cooling and drying as great glaciers formed and retreated, sculpting climates and carving seasons across the globe. Around 60 million years ago, a deep rumble in the Earth shook the balance of the atmosphere. A mighty volcanic episode unfolded in the northern Atlantic. Enormous eruptions spewed gases into the sky, and among them vast amounts of carbon dioxide. The lower layers of the atmosphere and the wide waters of the oceans began to warm. Yet this was not all. Along the edges of the continents, deep in the sediments that lay buried beneath the seas, methane had been trapped for ages. The warming disturbed it, freed it, and released it into the air in colossal amounts. This sudden release pushed the climate into a thermal peak, a time of fierce heat when the Earth's weather shifted violently. It was during this moment of fiery change that mammals, those small and often hidden creatures, found their chance. With reptiles weakened and birds struggling, the mammals began to spread and to transform. Some learned the mastery of water, gliding and swimming with strong strokes. Others stretched skin between their limbs and felt the first glimmers of flight. While animals struggled and thrived, the face of the Earth itself was far from still. Along the western edge of the Americas, the Cordilleras, the mighty mountain ranges, underwent powerful upheavals. The land twisted and folded, peaks rose and valleys sank. Far across the oceans, Europe itself was dragged downward into a subduction zone and pushed ever closer to Africa. When the two continents pressed against each other, mountains were thrust upward, forming ranges such as the Alps. On the edges of the Persian Gulf, folding lifted more ground, while far to the east, India pushed against Asia, sliding beneath it and lifting the colossal Himalayas into the sky. These mountain births would shape winds, rains and climates for ages to come. About 34 million years ago, the Earth shifted once more. The wandering of the continents brought a major change in climate. Global temperatures fell and the seasons became more sharply marked. Where once warmth lingered evenly across the year, now summers and winters pulled apart. The shallow sea that had once separated Europe from Asia shrank and withdrew, its waters regressing and leaving dry land in its place. New pathways opened for animals and plants, allowing them to cross into lands they had never before reached. Soon after, North America itself separated more completely from northern Europe and Scandinavia. The warmth that had once dominated gave way to new cold ages. Ice spread across great portions of the globe. The shaping of mountains, the Cordilleras of the Americas, the Alps of Europe, closed seas and shifted waters. The Caribbean Sea and the Great Tethys Ocean shrank until their passages closed. The link that had once allowed the warm Atlantic waters to flow freely into the Pacific was severed. Now, instead of warm waters circling the equator, sea currents were drawn more from north to south, particularly in the Atlantic Ocean. This redirected flow chilled the world further, plunging it into repeated freezes. Around 23 million years ago, the southernmost continent, Antarctica, felt the full grip of ice. Surrounded by ocean currents that wrapped around it like a barrier, warm waters could no longer reach its coasts. The great landmass became a frozen giant, sealed off, and transformed into a reservoir of cold that influenced the entire planet. Some believe that even the tilt of the Earth's axis added to this change. With its axis tipped, parts of the Earth received little sunlight for long stretches of the year. The seasons deepened, and the average temperatures sank lower still. The world grew colder and drier. Forests that had once stretched across vast regions thinned and retreated. In their place spread wide savannas and open steppes. The very look of the Earth's landscapes was transformed. Herbivorous animals, once content to feed on the tender leaves of trees and shrubs, found those meals disappearing. In their place grew grasses, stubborn and tough, spread across endless plains. The change disturbed not only the plant-eating animals but also the hunters that fed upon them. Species faced a harsh choice: adapt or perish. Small forest herbivores that had fed on soft leaves dwindled away, their food gone. In their place rose great grazers, animals capable of cropping the stubborn grass in huge quantities. The wide grasslands encouraged the rise of species built for speed, animals that could run swiftly across open ground, fleeing predators or chasing prey over long distances. But grass was not kind food. Compared to leaves, it was less rich in nutrients, and its tough fibres wore down teeth rapidly. Herbivores were forced to eat endlessly, day after day, just to take in enough energy to live. Evolution answered this challenge by reshaping their mouths. New species appeared with teeth that grew continuously, never wearing away fully. Rodents developed such teeth, always sharpening and lengthening. Horses too, whose ancestors were small forest dwellers, evolved tall teeth that could endure the grinding of endless grass. This adaptation allowed them to survive in a world where softer foods had vanished. Many ancient mammals, once rulers of their small corners of the forest, could not endure these changes. They vanished, swept away by climates they could not master and diets they could not adapt to. In their absence, other groups surged forward to take their place. Rodents, quick breeding and adaptable, filled every niche. Ruminants, with their specialized stomachs that could draw nourishment even from the harshest grasses, spread across the plains. Modern carnivores, leaner and faster, rose to hunt them. A new age of mammals had begun, shaped not only by their own bodies but by the turning of the earth, the rise of mountains, the shifting of seas, the fall of forests and the spread of grasslands without end. The story of mammals is one of constant change, where new forms appeared over millions of years, and among them rose true giants that could almost rival the greatest dinosaurs of ancient times. At the very beginning, the mammals that crept through forests and plains were tiny mouse-sized creatures with fragile bones and sharp little teeth. They lived quietly in the shadows, often at night, hiding from the immense reptiles that still ruled the land. It was precisely because they began so small that the later path of evolution pushed some of them to grow ever larger. Being small has its advantages in concealment, but it also carries many dangers. A tiny animal is easily swallowed by predators, it cannot store much energy, and it must spend a large part of its life in constant search of food. Nature answered this problem by favouring those lineages that slowly grew in size. To become large was to gain protection. An enormous body could scare away enemies that might think twice before attacking. Crocodiles might hesitate before biting into such bulk, and even a pack of carnivores might find the task too costly. Large animals could also move with greater authority across their landscapes, pulling down leaves, breaking branches, and trampling smaller rivals out of their way. There was also another quiet advantage. Big bodies help to keep a steady temperature. While smaller animals lose heat quickly and must burn more energy to keep warm, massive ones hold on to their warmth more easily, needing less food to maintain their internal fire. But to grow into giants was not without its price. A giant eats like a giant. The amounts of vegetation required to feed such a body are staggering. Grass, leaves, bark, shrubs and branches must all be consumed in endless cycles to keep those bellies full. As a result, large herbivores could never be as numerous as their smaller cousins. Their populations would always be thinner, spread over vast territories, and in times of crisis, famine, or sudden climate shifts, they were more vulnerable to extinction. Among these giants walked the Baltherium, an extraordinary creature that resembled a rhinoceros but without the familiar horn. Stretching to about 5 meters in length, or 16 feet from nose to tail, it was the greatest of its group and one of the largest land mammals ever to exist. The Baltherium towered above the savannas, able to reach the highest leaves of trees much like the giraffe of today. Yet where the giraffe is graceful and slender, the Baltherium was heavier, stockier, and its weight could reach up to 15 tons, far surpassing its modern counterpart. Despite such immense bulk, it was not invincible. Crocodiles lurking in rivers and formidable predators roaming the plains would still dare to attack, for no creature is beyond hunger's call. Sharing these lands were the intellents, distant cousins of today's boars and warthogs. They were easily recognized by their massive heads, which bristled with strange bony growths and outcroppings. With sturdy bodies and sharp tusks, they lived as omnivores, feeding on whatever could be dug, chewed, or torn apart. Roots were pulled from the soil with their powerful snouts, small animals were seized in quick bursts of attack, and plants were consumed when other food was scarce. Among these intellents roamed the formidable Dinosaurs, a beast nearly 2 meters tall, which is about 7 feet and weighing close to 1.5 tons. It was no delicate grazer, but rather a scavenger with immense jaws capable of crushing the bones of dead animals. When carcasses lay rotting under the sun, Dinoeus would stride in, jaws snapping, reducing skeletons to fragments as it tore into the leftovers left by other hunters. Another mighty form to appear was the Megatherium, a colossal member of the family related to the modern sloth. Unlike the tiny tree-dwelling sloths we know today, Megatherium was too immense to climb. It stretched nearly 6 meters long, or about 20 feet, and weighed as much as 4 tons, equal to a modern Asian elephant. Moving slowly upon its 4 heavy limbs, it could, when necessary, rear up on its hind legs, its enormous body looming like a living tower. Its claws were long and curved, perfect for pulling down tree branches. With these weapons of nature, Megatherium gathered leaves within reach of its grinding teeth, crunching steadily as it fed. It was a patient eater, a slow mover, but an undeniable presence in its world. As time passed, landscapes themselves changed. Forests that once stretched endlessly began to thin out. In their place, grasslands spread, rolling savannas covering vast distances. The new plants demanded new strategies. Grass grows differently than tender leaves. It sprouts from its base, regrowing quickly when it's cut or grazed. Where climates allowed this constant renewal, grass-eaters thrived in great numbers. But grass was no easy meal. It was tough, fibrous, filled with silica that quickly wore down teeth. Old herbivores could not endure such a diet. They gave way to new species with better adaptations. Teeth became stronger, sharper, or continually growing to replace what was worn away. Stomachs changed too, developing chambers to break down and ferment the stubborn blades of grass. From this evolutionary path came the protooratids, early relatives of camels and llamas. Many of them carried strange horns upon their heads. One of the most curious was the Synthroceras, with a forked horn rising from its snout and an extra pair jutting from its skull. These ornaments were not merely for decoration. Males wielded them as weapons in fierce battles for dominance, clashing and locking horns in displays of strength. Females lacking these horns grazed in calmer fashion, leaving the males to settle their bloody disputes. About 35 million years ago, a new and highly successful group arrived, the ruminants. These hoofed herbivores had developed complex stomachs with several chambers, allowing them to ferment and digest the toughest grasses of the open prairies. Their teeth too evolved into a wonder of durability, growing continuously to replace the constant wear from chewing abrasive plants. They first arose in Asia, but their success carried them across continents into Africa and the Americas. From them came the ancestors of giraffes, deer, cows, and antelopes. Stranger still was the Haplotherium, a peculiar creature with 5 horns decorating its skull. One of these horns stood proudly from the middle of its forehead, while the others branched out in unexpected directions. Though barely taller than a goat, it bore 2 long canines like defensive daggers protruding from its mouth. Another odd form, the Cevatherium, one of the earliest giraffe relatives, lived in the lands of India. It looked more like a heavy-set elk than a giraffe, much shorter and more massive, and it carried grand horns upon its head. As the plant-eaters evolved, so too did their hunters. Early carnivores were small, nimble, often living in trees where they stalked birds, reptiles, or mammals weaker than themselves. Their diet was mixed, including fruit, insects, eggs, and meat. Over time, however, some of their descendants grew sharper claws, keener senses, and most importantly, teeth specialized only for cutting flesh. Thus emerged the true carnivores, animals devoted entirely to hunting and eating meat. 2 great lineages arose. One gave rise to wolves, bears, and even seals that later returned to the seas. The other produced hyenas, lions, tigers, and all the great cats. Among these predators, some became truly legendary, the saber-toothed hunters. Though often called saber-toothed tigers, they were not tigers at all, but separate lines of carnivores that developed similar weapons. Their upper canines grew into immense flat blades, some with tiny ridges along the edges. To make space for these monstrous teeth, their skulls changed shape, shortening their snouts and strengthening their necks. Their neck muscles were vast, allowing them to drive those teeth deep into prey. Their hunting style was brutal and efficient. They would leap upon large herbivores, sink their teeth into the throat and hold fast until the prey suffocated. Interestingly, saber-toothed predators appeared several times in history in unrelated groups, as if evolution itself kept reinventing this deadly design. Not only large predators thrived, smaller mammals also carved out their places. Rodents, with their endlessly growing incisors, became masters of survival. Their front teeth sharpened against each other with every bite, turning into natural chisels able to cut through wood, nuts, or roots. Behind these incisors, strong molars ground food into pulp. Long before true rodents, primitive creatures called multituberculates had similar teeth, being among the first plant-eating mammals. But when the multituberculates disappeared, rodents rose and spread across the earth. Today, nearly half of all mammal species belong to this group, a testimony to their success. The first rodents appeared in Asia, but their adaptability allowed them to colonize every continent, even reaching distant Australia. Some learned to swim and build dams like the beavers, reshaping entire rivers. Others climbed into the trees, leaping from branch to branch. Still others dug deep burrows beneath the ground, carving hidden cities of tunnels. Most rodents stayed small, but there were exceptions. Among them was the giant Forberames, a cavy related to guinea pigs and capybaras, which grew to nearly 700 kilograms, or about 1,500 pounds. Imagine a rodent the size of a horse grazing along riverbanks. Such creatures once lived, their bones now silent reminders of lost ages. Yet another remarkable family that dominated this era were the proboscideans, ancestors of elephants. The earliest among them was the Merotherium, a squat animal about the size of a pig. With short legs and a massive body, it spent much of its life in water, feeding on aquatic plants. It had no trunk but possessed a thick, flexible upper lip that helped in gathering food. Later, some species began to develop a short trunk, a fusion of nose and lip that proved incredibly useful. Over countless generations, the trunk lengthened and strengthened, becoming the versatile tool we know in elephants today. The large head of these animals needed to carry strong jaws and heavy teeth was best supported by a short neck. But with a short neck, reaching for leaves became difficult. The trunk solved this problem, serving as an arm, a nose, and a hand all at once, a masterpiece of evolutionary design. Through all these ages, Earth was never still. Great extinctions swept across continents, erasing entire families of animals. Each crisis was a tragedy, removing diversity and breaking ancient chains of life. Yet, strangely, these losses also opened doors. When one group vanished, others stepped forward, filling the empty niches with new shapes and behaviors. Ecosystems reshuffled, predators found new prey, herbivores discovered new plants, and life continued in altered forms. The record of these changes lies buried beneath our feet, in fossilized bones turned to stone. From those bones we learn that the parrot was not always a parrot, the dolphin not always a dolphin. Each form we see today is the latest chapter of an endless rewriting of life. The world of today is not the world of yesterday. Our planet has been shaped by chance events, asteroids from space, shifts in climate, changes in seas and lands. Each time, some species perished, while others survived and flourished. Among the survivors were the ancestors of modern humans. Though humanity itself does not yet appear in these chapters, its roots are already present, hidden in the forms of small mammals that endured while giants fell. Without the disappearance of the dinosaurs, it is certain that we would not stand here now to ponder these stories. It was about 50 million years ago when the world found itself wrapped in a heavy cloak of heat and moisture. The fiery chaos and choking dust that had followed the Great Extinction at the end of the age of the dinosaurs had finally faded. The roaring noise of destruction, the crashing of falling giants, and the silence that had followed were now distant echoes. The planet, free from those apocalyptic tremors, began to breathe differently. It was not a world of fire anymore, nor a land blasted by fallout and emptiness. Instead, Earth was sweating. Not with fear, but with life. Heat rose like a blanket across valleys and lowlands. Humidity wrapped itself around every surface, and rainforests stretched their fingers farther and farther, creeping into lands that had once been too dry or too barren to welcome them. The age that scientists call the Paleocene had ended, and now the Eocene was beginning. The air was thick with carbon, but this was no poison. It was fuel for plants. Oxygen followed, rising high, filling the lungs of creatures that were still small and scrambling to find their places in this new experiment that Earth was staging. Everywhere across the equatorial belt and stretching outward toward the poles, the land was changing. River deltas grew fat with silt and green shoots. Floodplains widened and drowned in seasonal rains. Marshes and swamps spread in dark, glistening patches that shimmered under the canopy of towering trees. From the steaming wetlands of what is today Southeast Asia to the soggy lowlands of the land that would one day be called the American Gulf Coast, the same pattern appeared. A new stage had been set, one damp with mud and shadow, buzzing with insects, tangled with roots, and alive with endless noise and movement. These swamps and wetlands were not simply survivors of the extinction that had wiped away the giant reptiles. They were builders, rewriting the very rules of life. For the mammals, still modest, still mostly hidden in the cast of living things, this was the arena where their true revolution began. The muddy basins, the shadowy groves, and the buzzing marshes were not just backgrounds. They were classrooms, laboratories, and proving grounds all at once. The fossil record of this time is uneven, broken in places, like a book with pages missing. Yet even in those gaps a story emerges. By 50 million years ago, the wettest corners of the world were also its most creative and chaotic. Life began layering itself in ways it never had before. The ground no longer held everything. The branches of trees became new highways, the vines became bridges, and the canopies became floating cities. The swamps, bogs, and floodplains stacked life vertically, creating a three-dimensional puzzle of existence. Some animals darted through the undergrowth, others slipped silently through the water, while new climbers reached upward, balancing on branches, twisting through vines, or leaping from tree to tree. For mammals, this was an open invitation. Their bodies, still small, many no longer than a human's forearm, most shorter than a meter in length, began to change in subtle but important ways. Limbs became more flexible, hands and paws more versatile. Some developed digits that could oppose one another, not only to grasp food but to cling to bark or vines. Claws, once meant for digging, curved more elegantly for climbing. Eyes shifted forward on the skull, narrowing the world into sharper focus and giving them depth perception in a place where a misstep could mean a fall into mud or water. Tails grew longer, acting like ropes of balance. Bones themselves lightened, bending more easily, letting these small mammals move gracefully across branches that swayed in the wind or logs that floated unsteadily in dark, slow water. Here, in these damp worlds, mammalian agility became not merely a tool but an art. It was no longer just about surviving day to day, but about mastering rhythm, timing, and the challenge of a tangled stage. In the shale beds of Wyoming's Green River Formation, preserved in astonishing detail, we find whispers of this story. Leaves pressed into stone look as if they only just drifted to the ground. Insects, their wings still delicate in fossilized impressions, tell us of the buzzing swarms that once filled the skies. Fish rest in layered sheets of rock, their scales still shimmering in patterns of preservation. And occasionally a small mammal appears. Among them is Eocene, a creature no longer than a squirrel, once thought to resemble a hedgehog. But closer study of its bones shows a spine more flexible than expected. A body built not for slow crawling but for quick bursts, agile turns, and perhaps even for climbing. Its middle ear hints that it could hear well, maybe even communicate in high-pitched squeaks like modern shrews. It darted between rotting logs and tangled roots, vanishing into undergrowth or climbing into low shrubs. Small though it was, Eocene was part of something larger, proof that mammals were starting to use complexity as a weapon. What made these wetlands such powerful engines of evolution? The answer lies in their very instability. They were rich with food, fruits, seeds, insects, fish, small reptiles, but nothing was steady. Rains came in seasons. Rivers rose and then shrank. Plants grew fast, then rotted just as quickly. Waterlogged soil shifted underfoot, and storms could flatten whole sections of forest. To live here was to live on the edge of change, A creature could not survive with one single trick. It needed a whole toolbox of strategies. Flexibility became the law, and mammals, with their warm blood, quick reproduction, and versatile diets, were well suited to obey that law. Some clung to tree trunks, their claws sharp and steady. Others leapt from branch to branch with surprising grace. A few darted like shadows through reeds and grasses, always ready to vanish when danger struck. Over time, this led to an explosion of forms. Bodies lengthened or shortened, tails became paddles or anchors, eyes widened to drink in the dim green light. Each adjustment was a small step in a much larger dance, and evolution was the choreographer. Sound became just as important as sight. In these dense forests, vision was often blocked by leaves, vines, and fog, but sound carried. Calls echoed across swamps. The slosh of water, the snap of twigs, the faint scratching on bark, these were signals of survival. The middle ear bones of early Eocene mammals show refinements over their Paleocene ancestors. These refinements were not accidents, they were necessities. If you could hear a predator's approach before you saw it, you might live another day. If you could call to a mate in a frequency others could not detect, you might pass on your genes. A mammal's nervous system became not just a machine of instinct, but a growing web of perception and learning. The true wonder of this age was not any single animal, but the structure of life itself. Wetlands divided and layered the world. The ground was no longer a flat stage, but a crowded city with levels. The roots of trees formed dark tunnels for creatures that skittered and swam. The understory became a tangled maze for clingers and leapers. The canopy stretched like a roof, pierced with beams of light where gliders might cross. Above even that, the sky opened briefly, letting birds wheel and dip. No other habitat on Earth at the time was so complicated, so full of vertical and horizontal opportunities, and mammals, ever the opportunists, rushed in to fill them. Danger was everywhere, but danger itself became an opportunity. In swamps, footing was treacherous. Predators could hide in murky waters or behind sudden curtains of leaves. Storms could wipe out food sources in days. But in this chaos, the creatures that could learn, adapt, and recover fastest were the ones that thrived. It was not just strength that mattered anymore. It was the ability to move through uncertainty without collapsing. The plants were also changing. Flowering plants spread widely, evolving alongside the animals that fed on them. Fruits appeared, rich with sugars, tempting mammals to carry their seeds. Tubers grew in the muck, waiting for claws or snouts to dig them up. Flowers invited pollinators, and those pollinators invited predators. Food webs became tangled, as complex as the vines hanging overhead. Insects multiplied in astonishing numbers, buzzing clouds that provided endless meals for those nimble enough to catch them. The strangest experiments of this time did not come from the ancestors of the massive mammals that would later roam open plains. Instead, they came from the swamp dwellers. Here, creatures pushed the limits of form, ankles stretched into long springy joints, tails twisted into prehensile ropes, snouts lengthened, nostrils creeping upward to keep breathing while heads dipped underwater. Convergent evolution happened in overdrive. A small mammal in Asia might begin to look strangely like a marsupial in South America, though their families had split long before. In the dense green world, function mattered more than ancestry. Fossils show that species turned over quickly. A form might rise, adapt brilliantly for a short time, and then vanish when the swamp shifted or new competitors appeared. These were not gentle Edens, but roiling arenas where only the clever and flexible survived. Natural selection here did not favour brute force. It rewarded nimbleness, adaptability, and resilience. Not all mammals climbed. Some dipped into the water, experimenting with semi-aquatic life. Their bones grew denser, helping them sink rather than float. Their feet flattened, toes spreading wide, hints of webbing forming. Their nostrils began creeping higher on the snout, the earliest whispers of the whales to come. The wetlands were not just vertical, they were amphibious. And for the mammals bold enough to wade in, the path eventually led back to the ocean itself. Yet, there was no single hero of this story. No creature stood up and declared itself the future. It was all quiet, layered, and patient. One grasp of a branch, one careful leap, one squeak in the darkness. All of these were steps towards something greater. The swamp was not an ending, but a forge. It was where mammals learned balance, timing, and resilience. Why did the future of mammals begin in the mud? Because mud is where complexity lives. Mud is where roots twist and water rises and falls. Mud is where rot feeds new growth, and where every creature must stay alert to survive. In mud, life is forced to grow, not just stronger but smarter, to sense rhythm and change, to coordinate movement and thought. And if you trace yourself back far enough, through the agility of your limbs, the coordination of your balance, the sensitivity of your ears, you might find that your body remembers. Somewhere deep inside, in nerves and reflexes, is the echo of that swampy classroom. A memory of when small, anonymous mammals learned to climb, to leap, to listen, and to imagine a life beyond mere survival. So when you step into a forest today, when you hear water trickling through roots or insects humming in the shade, you're hearing the ancient music of your own beginnings. It was in the quiet, slippery, buzzing depths of those long-vanished wetlands that mammals first began their true ascent, building futures out of mud and motion, one tiny heartbeat at a time. There are certain turning points in the long story of the Earth when nature seems to look backwards, almost as if it remembers a melody it once played long ago and wants to hum it again. It is as though some deep and ancient memory hidden in the code of life begins to stir, whispering that the planet once carried giants, being so large, so loud, and so impossible to ignore that they seemed like walking landscapes. After the time of the dinosaurs ended, when the ashes of the great extinction still lingered and silence still hung over the scarred world, such a memory began to surface again. Evolution, never content to remain still, decided to try something bold. It tried once more to bring forth giants, but these new giants were not built in the image of the old lords of the Mesozoic. They did not wear scales like armour, they did not flash teeth as long as a man's arm, nor swing tails that could topple trees in a single sweep. These giants were stitched together differently. They were creatures of fur instead of scales, of bone instead of reptilian cartilage, of heavy bodies that lived on calories pulled from plants. Some of them resembled massive, thick-skinned rhinoceroses. Others looked like exaggerated tapirs, carrying strange and comical horns upon their heads, horns that made little sense to modern anatomy. They were not elegant, they were not subtle, but they were proof that life was recovering from the catastrophe that had ended the dinosaurs. It was about 45 million years ago. The world was still warm, humid, and restless, and the land was buzzing with energy. North America and Eurasia were the stages upon which this new drama unfolded. Forests cloaked most of the continents, vast green seas of trees stretching farther than the eye could travel. Grasses, the plants that would later cover half the earth and transform everything, had not yet risen to dominance. Instead, the land was filled with ferns, vines, flowering plants, and endless trees so thick that one could lose an entire parade of elephants in their shadow. Where there were leaves, there were mouths. And where there were mouths, nature's hand began to draw them larger and larger. Among the most striking of these giants were the Brontothrees. If you were to imagine a rhinoceros, then stretch it, bulk it up, and give it a head almost comically too large for its body, with a horn shaped like the letter Y rising from its face, you would begin to see them. These horns may not have been good for fighting, nor very practical at all, but they certainly left paleontologists puzzled and amused. The Brontotheres, also called Titanotheres, belonged to a group of odd-toed hoofed mammals that would dominate the northern continents during the Eocene epoch. They could reach lengths of more than 13 feet and weigh more than 2 metric tons. This was no small accomplishment for creatures whose ancestors had once been tiny hoofed animals, creeping quietly through ancient undergrowth, scarcely larger than house cats. Evolution had taken those timid little forms and inflated them into monsters of the forest. But the Brontotheres were not alone. They were only one verse in a whole chorus of strangeness. Other massive herbivores appeared, equally bizarre in shape and design. There was the Uintatherium, a beast that looked like a child's wild attempt to draw a mammal without any rules. It carried a body somewhat like a hippopotamus, a heavy skull covered with bony knobs and horn-like bumps, and long saber-shaped tusks protruding from its jaw. Its skull alone could stretch more than 2 feet, yet the cavity for its brain was embarrassingly small. If cleverness had been the ticket to survival, These animals would have disappeared before noon. But survival in this world was not about brains, it was about stomachs. These giants did not need to be fast or intelligent. They needed to eat, and they needed to digest. The forests of this warm world were thick with leaves, but many of those leaves were tough, fibrous, and chemically defended with toxins or bitter compounds. Only creatures with vast stomach chambers and elaborate fermentation systems could make a living on such fare. The Brontotherians and Wintertherium were essentially walking factories of digestion. Their enormous bellies churned with bacteria that broke down cellulose and released energy. Their jaws worked tirelessly to grind leaves, stems, and branches into pulp. They were slow, they were simple, but they were efficient. In a world without fast predators or sprawling grasslands, efficiency was enough. They lumbered across continents as living fermentation tanks, moving piles of flesh fueled by the sun's energy stored in plants. Their bodies were the engines of a new kind of ecosystem, one not ruled by speed or sharpness, but by persistence and weight. The energy of this period came from the plants. After the great extinction that ended the age of dinosaurs, vegetation had exploded back with fury. The air carried more carbon dioxide than in our own time, the climate was warmer, and the poles, though cooling, still carried no permanent ice. This warmth allowed jungles and forests to reach almost to the poles. The planet became a greenhouse of abundance, dripping with water, filled with layers upon layers of biomass. And where biomass gathers, large bodies can rise again. For this brief chapter in the Earth story, size was not a burden, but a blessing. Yet being a giant always comes at a cost. Large animals take longer to grow, longer to reproduce, and demand endless amounts of food. They are powerful in stability, but fragile in crisis. For several million years, however, the gamble worked. The fossil record shows their remains scattered across what is today Wyoming, Mongolia, Kazakhstan, and Central Europe. They walked through forests beside lakes, left trails along the edges of ancient rivers, and pressed their footprints into silt and mud where insects hummed above. The bones they left behind tell us not only of their size, but also of their struggles. Many skeletons show thickened joints, reshaped bones, and signs of arthritis, evidence that their massive bodies put them under constant strain. Their lives were slow, their injuries healed poorly, yet they pressed on. A 2-ton mammal walking through a forest reshaped the world simply by existing. Branches snapped beneath its mouth, young trees crumpled beneath its feet, and clearings opened where sunlight poured down to the forest floor. These were not just animals, they were engineers of their environment, shaping the forest in ways smaller creatures could never do. Their rise also reminds us of a larger truth in evolution: convergence. Again and again, across deep time, life has discovered the same strategy. The Earth seems to have an eternal appetite for giants. Dinosaurs filled the role of massive plant eaters, slow and heavy. Before them, some reptiles of the Permian had tried the same. And here, in the Eocene, mammals took up the torch. The details changed, the horns looked different, the skeletons told new stories, but the role was always the same: the lumbering giant that feeds on plants and sets the rhythm of the ecosystem with its sheer bulk. It is tempting to think that the age of mammals was merely a straight road leading to us, to humans, as if every step in the past were nothing but a rehearsal for our arrival. But the world of 40 million years ago was no rehearsal. It was complete in itself. These animals were not on their way to becoming something else. They were perfect for the world they lived in, perfect for the greenhouse Earth, for the forests that hummed with unseen insects, for the steamy air that wrapped the globe in green silence. To step into that world would be to step into a dream of endless leaves and the low thunder of giant footsteps. But even the most magnificent experiments come to an end. These great mammals did not vanish in a single catastrophe. They faded slowly as climates shifted, as forests thinned in places, as grasses began to creep across plains, and as new animals rose to challenge them. By 34 million years ago, the Brontotherians had walked their last. Wintertherium fared little better. Their bones became fewer in the fossil record, their shapes grew less varied, and eventually they were gone. All that remains now are teeth, fragments of skulls, and riddles for paleontologists. Why did they fail? Was it the slow cooling of the climate? Was it the rise of more efficient grazers who could live on the new grasslands that were beginning to spread? Was it the sharpening of predators who learned to run faster and strike harder? The Earth guards its secrets closely, and the fossils never give perfectly neat answers. What we can see is that size, for all its power, does not grant immortality. The very weight that made them kings in one age became their weakness in the next. Yet for that shimmering span of time they ruled, not with cleverness or speed, but with mass and presence. They shook the ground, parted forests, and reminded the planet what it was like to host giants. Their story is one more verse in the great song of life, a reminder that the Earth has always been a place of experiments, of forgotten symphonies, of dreams that last a few million years before fading into silence. If we could somehow travel back in time and walk through the thick forest that covered what is today North America, or wander across the wide floodplains that stretched across Europe during the age called the Eocene, around 40 million years in the past, the world would appear both familiar and strangely alien. At first glance, the animals roaming there might not remind anyone of the predators we know today. There would be no lions stalking silently through tall grasses, no wolves running together in hunting packs, no leopards or tigers slinking through shadows, and no great cats lying in ambush. None of the modern tools of predation that define our current world had yet been invented by evolution. Yet despite the absence of these familiar hunters, a traveller in those lands would not be safe. The Eocene world carried its own dangers, for it was during this period that mammals themselves, for the very first time since the age of the great reptiles had ended, rose to claim the throne of predator. These creatures did not live in the treetops nibbling on fruits and hiding from larger threats. They were not gentle grazers chewing leaves or timid foragers scratching at roots. They were animals that hunted, smelled out their prey, tore into flesh with savage determination, and killed not by chance but by profession. They were mammals, but they were predators, and their rise marked a turning point in the story of life on Earth. The first wave of true mammalian hunters, however, did not look or behave like the elegant killers of today. They were odd, often clumsy in appearance, and sometimes primitive in their abilities. Yet for tens of millions of years they were good enough to rule. They reigned without rival, filling the top slots of food chains on several continents. And then, almost as suddenly as they had risen, they faded away into extinction. When paleontologists dig into the layers of rock that preserve the record of life after the great extinction that destroyed the non-avian dinosaurs, a particular group of strange predators shows up again and again. They belong to a long-vanished order of mammals called the creodonts. These animals are not to be confused with the carnivores we know today, the order Carnivora that includes cats, dogs, bears, hyenas and weasels. The creodonts were separate, belonging to their own order, now completely extinct. And yet, during their long age of success, they filled many of the same roles that today are taken by wolves, hyenas, lions, and leopards. The very name creodont gives away their character. It comes from the ancient Greek words kres, meaning flesh, and odus, meaning tooth. These were the flesh-toothed mammals, creatures that lived and thrived on tearing apart the bodies of others. In the later part of the Eocene, they were everywhere. Some of them reached enormous sizes. The largest of the group, like the terrifying predator known as hyaenodon, could grow to the size of a small bear. It carried a skull that seemed stretched out like a long weapon, filled with slicing teeth built for shearing meat, and jaws hinged in such a way that they could deliver a devastating bite. The name hyaenodon is misleading to modern ears, for it was neither a hyena nor a dog. It was something altogether different, a line of predator that has no living descendants today. Yet for its time, hyaenodon was one of the most successful carnivores the world had ever seen, roaming across what would one day become North America, Asia and Europe for millions upon millions of years. Other creodonts grew even larger still. One of them, the beast called sarcastodon, may have weighed close to 1,000 kilograms according to some estimates. Imagine an animal of that size, nearly the bulk of a small rhinoceros, moving across ancient open forests and wetlands in search of flesh. Sarcastodon and its kin may have hunted the early giant herbivores that were beginning to appear, lumbering hoofed mammals that browsed on the leaves of trees or grazed the growing grasses along riverbanks. They may have been hunters at times and scavengers at others, moving more like hulking bears than like the fast and elegant cats of later ages. With massive heads, long jaws, and a sense of smell that could lead them from great distances to death and decay. They were the blunt instruments of the mammalian predator world. Their competitors were not lions, leopards, cheetahs, or canines. Those animals had not yet come into existence. The evolutionary toolkit of modern predation had not been invented. The world of 40 million years ago had to improvise, so evolution tried something else. The creodonts carried teeth specialized for cutting through flesh. Their premolars and molars had become long slicing blades, known as carnassials, that could shear muscle and crack bone. But for all their terrifying jaws, their brains were small. Their hearing and eyesight were not remarkable. They were not the graceful, clever, or lightning-fast hunters that we imagine when we think of predators today. They were slower, less precise, more brutal. They were not surgeons of death, they were hammers. Yet for their world, they were enough. While these massive flesh-toothed beasts ruled the Eocene, another quieter story was unfolding. A small lineage of mammals was living in their shadow. These were the early ancestors of the true carnivores, the order Carnivora that today includes the cats, dogs, bears, weasels, hyenas, and seals. In their early days, these ancestors were unimpressive. They were small, often the size of a modern raccoon, with flexible diets that allowed them to eat almost anything. They were generalists, capable of scavenging, foraging, and sometimes hunting smaller prey. They lived on the margins, overshadowed by the far larger and stronger creodonts. They could not compete in strength or in bite. For tens of millions of years they were pushed to the side, odd creatures waiting for a chance that had not yet arrived. But history is full of such moments, when the eventual champions are not the mighty rulers of the age, but the overlooked survivors clinging to the edges. For the time being, the creodonts wore the crown. What made them successful was not elegance or efficiency, but timing. The world of 40 to 35 million years ago was warm and rich with forests. It was full of mammals at every level of the food pyramid. Small insect-eating mammals, climbing browsers, and the early hoofed herbivores provided abundant prey. The top of the pyramid was wide open. There were no large birds of prey in these habitats to fill the role of eagle or vulture. The great reptiles that had once dominated had vanished forever, and the cats, dogs, and saber-tooths of the future had not yet appeared. Into this empty throne stepped the creodonts, shaggy-jawed, small-brained, flesh-toothed beasts that claimed the role of king. Yet evolution never rests. Over time, the weaknesses of the creodonts began to matter. They reproduced slowly. They may have carried their young in long pregnancies, producing only a few at a time. They lacked the flexibility of behavior that would later define the true carnivores. Their limbs were not well built for chasing or for leaping. They were more plodders than runners. Most of all, their brains seemed frozen in size, unable to keep pace with the increasing complexity of ecosystems as the Eocene world grew richer and more varied. Meanwhile, the little generalists of the order Carnivora were quietly experimenting. The early miacids and viverids were small, fast, and adaptive. They could climb trees, they could scavenge a carcass, they could hunt a variety of prey, they could live in places the creodonts ignored. Their flexibility was their gift. Slowly, almost invisibly, they began to spread. And though it would take millions of years, the balance of power was shifting. The reign of the creodonts was not eternal. A coup was coming. One of the most fascinating traits of these early predators was their reliance on smell. Sight and hearing may not have been their greatest strengths, but their noses were extraordinary. Their nasal passages were large, and the parts of their brains devoted to processing scent. The olfactory bulbs were highly developed. In the dark corridors of the ancient forests, these animals may not have hunted by stalking silently like cats, or by outrunning their prey like wolves. Instead, they followed the faintest trails of scent with patience. They tracked not in sudden bursts but in steady persistence, guided by the invisible map of smells. To an early herbivore, danger may not have come in a sprint across an open plain, but in the slow, inevitable approach of a predator that had locked onto its scent hours earlier. Scavenging also played a vital role. In a world still reshaped by the extinction of the great reptiles, carcasses would have been plentiful and energy was precious. Some creodonts may have behaved like the hyenas of today, not hunters of elegance but scavengers of efficiency, cracking bones, devouring carrion, and recycling death into life. To us, predators are often imagined as sleek, majestic, and noble. But evolution does not care for beauty or style. It cares only for survival, for the continuation of life. In that measure, the creodonts succeeded brilliantly. They were not graceful, not clever, not fast, but they were efficient enough to dominate. This age marked a new chapter in the history of mammals. For the very first time, mammals rose not just as prey or opportunistic feeders, but as dedicated killers. These were animals whose very way of life was built around hunting and feeding on other vertebrates. It changed everything. The rise of mammalian predators forced herbivores to evolve new defenses. Some grew sharper hearing, others developed faster reflexes. Still others became more secretive in their behavior, hiding or moving more cautiously. For the first time in the age of mammals, ecosystems experienced what scientists today call a trophic cascade. Energy flowed from plants to herbivores to predators, and the top of the chain was no longer held by reptiles or birds but by mammals. Looking back, it is easy to think of these predators as failures because they are gone. The creodonts vanished sometime during the early Miocene, after ruling the world for tens of millions of years. Their evolutionary experiment ended, and their line disappeared. Yet in the grand measure of time, lasting tens of millions of years is not failure at all. It is success with an expiration date. The world changed, the climate cooled, new competitors rose, the more flexible, more intelligent and more agile carnivores eventually took their place. Still, one cannot help but wonder what might have happened if the story had been slightly different. What if the brains of creodonts had grown larger? What if they had become more adaptable in their behaviour? Could we be living today in a world where the top predators were not cats or wolves, but descendants of those slow-brained, heavy-jawed beasts with their massive heads and endless hunger? Would our forests and plains echo not with the roar of lions, but with the deep bellowing calls of creodonts that never vanished? Perhaps their story was an evolutionary test, a draft version of mammalian predation before the final shape was perfected, or perhaps it was a destiny always meant to end, clearing the way for new forms of life. For tens of millions of years after the fall of the mighty dinosaurs, the Earth seemed to lean into a strange and beautiful dream. It was a dream of warmth, of constant humidity, of endless greenery. The planet wore a greenhouse skin, a warm cloak that wrapped around even its coldest corners. Palms stretched their feathered fronds almost to the very poles. Crocodiles drifted lazily in swampy waters that today we would call the high plains of Wyoming, a place now better known for its snow, mountains, and dry air. Back then, the world was so different that it almost feels like a fantasy. For a long moment in geological time, a moment that lasted not hours or days or centuries but millions upon millions of years, it seemed as if jungles would forever reign. The forests were thick, moist, and heavy with life, as though the entire planet was one giant greenhouse garden. But nothing on Earth lasts forever, not even paradise. Around 35 million years ago, that great humid dream began to unravel, and it did not slip away gently. It was not as if the trees simply faded and the air cooled with little fuss. No, the green dream died with drama, with sudden sharp turns, with cascades of changes that shocked life on every continent. It began, as so many planetary tragedies do, with movements so slow that no creature alive could notice them. Continents were always drifting inch by inch across the globe, pulled by the restless plates beneath. Their collisions and separations had been shaping oceans and mountains since the beginning of time. To the animals living in the lush forests, such motions were invisible. But by the closing chapters of the Great Warm Age we call the Eocene, the Earth's atmosphere had already begun to falter, as if the invisible balance that held the warmth in place was cracking. Antarctica, which for millions upon millions of years had been blanketed in forests and swampy green lowlands, was slowly drifting into solitude at the southern tip of the planet. Once it had been connected to other lands. Now it was peeling away, isolated at the bottom of the world. And then, as though a giant hand reached down and flipped a switch, everything changed. Ocean currents shifted direction. Moisture patterns faltered. The invisible machinery that delivered rains and warmth to the jungles stopped working, and where palm trees had once swayed, snowflakes began to fall. What followed was one of the most astonishing and brutal climate shifts in the past 100 million years. It was not a single thunderclap moment like the asteroid strike that had ended the reign of the dinosaurs. It was instead a cascade, a series of changes linked together, one pulling the next like falling dominoes. The Eocene-Oligocene transition was a cliff in the history of climate, a sudden drop that destroyed entire ecosystems, rewrote the rules of survival, and reintroduced something the Earth had not felt in a very long time: serious, sustained cold. This was no gentle cool breeze ruffling the trees. This was the birth of what scientists call an icehouse world. For the first time in more than 30 million years, the great continent of Antarctica froze. It became a land of glaciers and permanent ice sheets. The seas responded by falling as water was locked up in frozen prisons. Global temperatures dropped by roughly 4 to 5 degrees Celsius, a number that sounds modest when we speak it aloud, but that was powerful enough to push entire ecosystems off the edge. The evidence lies in the fossils scattered across Europe, North America, Asia, and Africa. We see lush subtropical forests thinning, their once proud canopies shrinking until they vanish altogether. The variety of plants collapsed. Insects which had flourished in the sticky warmth fell into sharp decline. The once rich and dripping jungles filled with shade and dripping leaves gave way to open woodlands, thickets, and scrubby plains. Rain, that lifeblood of all things green, weakened and faltered. In some places it became erratic, in others it vanished almost completely. Antarctica, once swampy and green, transformed into a continent wrapped in white. Sediments pulled up from the Southern Ocean tell us how fast it happened. Glaciers began their advance with shocking speed. Tiny shelled creatures called foraminifera, drifting through the sea and building their fragile homes of calcium, became unwilling recorders of disaster, their shells locked in the chemical story of the waters they floated in. And that story was grim. The oceans were becoming colder, denser, less welcoming to life. The great question that rises is, what caused such a turn? The most convincing suspect remains the slow separation of Antarctica from its neighbours. When Antarctica drifted apart from Australia and South America, a new channel of water opened, known as the Drake Passage. This gap allowed the birth of the Antarctic Circumpolar Current, a relentless conveyor belt of icy water that circles the continent without pause. It was as though Antarctica had been given its own personal air conditioning system, one that could never be switched off. Once the ice began to spread, it only fed upon itself. Ice reflects sunlight instead of absorbing it, which cools the surface, which allows more ice to form. Clouds thinned as evaporation slowed, which meant fewer greenhouse effects to trap warmth. Volcanic eruptions tried from time to time to push carbon dioxide into the air, warming things slightly, but the tide had turned. The Earth was locked into a new age. The greenhouse paradise had been evicted, replaced by the first true glacial landlord in tens of millions of years. What happened to the living beings who had thrived in the warmth? Many did not survive the transition. This extinction event was quieter than the asteroid strike that had ended the Cretaceous period, but it was no less merciless. Entire lineages of warmth-loving plants disappeared. Amphibians and reptiles that had basked in the humid swamps were wiped out. The rainforests of North America, once a heaven of palms, ferns, and giant salamanders, shrank into patchy remnants. Forest-dwelling mammals suffered heavy losses. Nor were the oceans safe. The cooling waters changed the way layers of the ocean mixed, disrupting the circulation of nutrients. Many deep-sea species perished. Coral reefs, those brilliant underwater jungles, weakened and declined. As ice pulled water from the seas, coastlines shrank, exposing shallow marine habitats to collapse. Creatures who had wagered their future on warmth suddenly found themselves without a place in the new world. Yet, as always in Earth's endless story, endings carried seeds of beginnings. Loss was paired with opportunity. As the world cooled, dried, and opened, new spaces appeared. Animals that could thrive in open plains, that could travel longer distances, that could graze on tough grasses rather than nibble soft leaves began to rise. Grasses themselves had been quietly evolving for millions of years in the background, waiting for their moment. Now the moment had arrived. They spread across landscapes where forests had once reigned. The canopy was no longer master. The age of endless jungle was broken. forests did not vanish entirely. In equatorial belts and in sheltered basins, patches of dense forest clung on, like isolated green islands in a sea of openness. But the dominance was shattered. For the first time in a very long span of time, life had to learn to live without the ceiling of leaves. In fossil beds across Central Asia and North America, we see the evidence of the new chapter. Grasses show up more often, woody shrubs spread, trees altered themselves to endure frost. Animals evolved teeth that could grind dry, tough plants. Their legs lengthened for running across open ground. Others dug into the soil for protection. Evolution, always a restless gambler, began throwing out new experiments to see who could survive. Perhaps the most astonishing thing about this transition is not only how deeply it changed the face of the Earth, but how fast it all happened. Geological clocks tell us that the major temperature drop took less than 500,000 years. 500,000 years may sound unimaginably long to us, but in the scale of Earth's deep time it is the blink of an eye. Imagine a world of dripping jungles transforming into a frost-bitten land of open scrub and icy seas in what amounts to a geological heartbeat. And through it all, life kept doing what it has always done. It adapted, it stumbled, it collapsed in places, then flourished in others. Species went extinct, while others rose from the shadows. No hand guided this transformation. No creature knew what awaited. It was all trial, error, chance, and persistence. Evolution moved forward, blindly but steadily, into a new world. If there is a single lesson whispered by the Eocene-Oligocene transition, it is that climate is never just background scenery. Climate is the stage, the script, and often the director of life's play. When the air cools, when the waters shift, when the ice returns, entire destinies of creatures and plants can crumble or soar. Paradise itself is not eternal. For tens of millions of years, the Earth was a greenhouse, its forests endless, its warmth unbroken. Yet all it took was the slow drift of continents, the opening of a watery doorway, and the merciless loops of ice and sunlight to end it all. There are turning points in the story of our planet that stand out like bright flashes in a long night. Sometimes they arrive suddenly and violently, like a cosmic rock tumbling from the heavens and crashing into the Earth, or like a supervolcano vomiting fire and ash until the skies go dark. At other times, the cold creeps down from the poles, and ice sheets march slowly southward or northward, smothering the land in silence. Those revolutions are easy to notice, for they roar, they crack, they shake, and they change everything in what feels like a single breath of geological time. But other revolutions take their time. They are not loud. They do not explode. They whisper. They creep. They start in hidden corners of the world, unseen and almost unremarkable, and they spread with a stubborn patience that no one notices until it is too late. Then one day, if you could step back and take in the whole Earth, you would realize that everything had changed, not because of an asteroid or a firestorm or an endless winter, but because of something so ordinary you might walk over it without thinking. This is the story of one of those quiet revolutions, the story of grass. Grass is one of the most unassuming families of plants on Earth, and yet it is also one of the most successful. It is not tall and majestic like a redwood tree, nor does it bear rich fruit like an apple tree, nor does it blaze with brilliant colours like wildflowers in bloom. It hides in plain sight, spreading in blades and tufts, never calling attention to itself. But it has been one of the most ruthless conquerors in the history of life. Grass did not simply cover the earth with green carpets. It rewired the very rules of existence. It changed what animals ate, how they lived, how they moved, how they evolved. It shaped the rise of entire ecosystems. It even prepared the ground for human beings, who would one day cultivate it, tame it, plant it in fields, turn it into food, and eventually mow it for decoration. But long before apes figured out how to cut lawns or grow wheat, grass had already begun its secret takeover. It crept across the lands of Africa, Asia, and Europe, and with every new blade that pushed through the soil, it prepared to flip the rules of survival. Who thrived, who starved, who ran, and who chewed. If you roll back the story to around 33 million years ago, the world was in the middle of great change. The warm age of the Eocene, that lush and humid chapter when rainforests sprawled far beyond the tropics, was coming to an end. The great southern continent of Antarctica had frozen into an icy desert. Thick forests that once stretched across continents began to retreat, peeling away as the air cooled and dried. In the atmosphere, the invisible gas of carbon dioxide, the breath of plants, was falling little by little. The levels were not yet low enough to smother life, but they were enough to shift the balance. The air was lighter now, thinner in its store of greenhouse gases. The heat softened. The heavy humidity that once pressed down on jungles lifted. Mid-latitude regions grew cooler and drier, and the old champions of the forest, the towering hardwoods, the dense canopy dwellers, found themselves retreating. Their once solid empire was shrinking, and into the space they left behind crept a new kind of ruler. The new rulers were lower, leaner, simpler in appearance, but infinitely more adaptable. They were grasses, members of a great botanical family called Poaceae. They were not new to the world. In fact, they had been lurking quietly in the underbrush for tens of millions of years, biding their time beneath the shadows of taller plants. But now, with the skies changing and the climate shifting, they finally had the advantage. For the first time in the history of life, the world tilted toward them, and they stepped forward with chlorophyll in hand. To understand why this moment mattered, you must try to see the world through the mind of a plant. Most plants that dominated the earth at that time used a process called C3 photosynthesis. It is the way they turned sunlight into food. It worked well in the cool, wet conditions of the earlier world, and it relied on plentiful carbon dioxide in the air. But as the air dried and as carbon dioxide levels dropped, that system began to falter. It became inefficient, wasteful, almost clumsy. For most plants, survival became harder. But grasses had something different. Something secret, a different kind of metabolism, a different photosynthetic engine. It is called C4 photosynthesis. And compared to the old C3 system, it was a weapon. It was faster, more efficient with water, more efficient with nitrogen, and it could keep running even under the blaze of hot sunlight and in the parched air of dry climates. Scientists still debate exactly when and where this C4 system first emerged, but evidence points to dry, open landscapes somewhere in what is now Africa or the Indian subcontinent. It seems to have been born among certain grasses in places where the rains came and went with the seasons, where heat bore down without mercy and where other plants withered. When the first grasses unlocked this hidden pathway, the course of evolution tilted forever. The genetic switch had flipped and destiny had turned green. Once grasses began using C4 photosynthesis, they spread like wildfire. They outcompeted their cousins who still relied on the less efficient C3 method. They crept into places once dominated by shrubs and the edges of forests. Their very architecture gave them an advantage. A tree invests in long years of growth, building huge trunks and branches that can take decades to form. But grass grows fast, dies fast, and grows back faster. You can burn it, graze it, trample it, and it returns again and again. Its most important growth point sits safely at or below the surface of the soil, where hooves, teeth, and flames cannot destroy them. Many plants suffer from disturbance. Grass seems to crave it. Fire makes it flourish. Grazers are not enemies, but partners in its cycle. In fact, grasses and grazing animals formed one of the most extraordinary partnerships in natural history. It was not a peaceful partnership, but a brutal feedback loop, where each thrived because of the other's violence. Grazers tore into grasses, chewing them down to stubble. In response, grasses grew back stronger and faster. Fires ripped across the land, but grasses rebounded while trees fell. Together, the plants and the animals created a self-sustaining machine that reshaped continents. By the time, between 29 and 28 million years ago, vast regions of Africa and Eurasia had been transformed. What had once been a patchwork of woodland and seasonal forest was turning into something new. It was open, bright, dry, filled with endless waving blades and shallow roots. The age of the forest floor was fading, and the age of the grassland was dawning. The change was not only about landscapes, it was about life itself. The new environment did not simply rearrange habitats, it rewrote the rules of eating, of survival, of evolution. Grass, for all its abundance, is terrible food. It is tough and fibrous, laced with tiny grains of silica that grind teeth down like sandpaper. It is poor in calories compared to fruits, seeds, or meat. any animal that tried to live on grass alone needed special equipment. It needed stronger jaws, harder teeth, or enormous guts capable of fermenting and digesting the stubborn fibres. The spread of grass therefore triggered a new kind of evolutionary arms race among herbivores. Only those who could chew longer, digest better, and bulk up larger would survive. Teeth grew higher, crowned to endure the grinding wear. Stomachs evolved into complex chambers to break down the tough meals. Legs grew longer so that animals could move quickly between patches of food. Suddenly being big and heavily jawed was not just an advantage, it was a requirement. The new grassland ecosystems also changed how energy flowed through the web of life. In dense forests, most of the energy is locked up in tall trunks, thick branches, and heavy wood that takes years to form and years to rot away. In grasslands, energy moved faster. Grasses grew rapidly, died rapidly, and fed massive herds of herbivores. Those herds in turn fed predators, scavengers, and even the invisible microbial armies that lived in the soil. The whole system accelerated. Life sped up. Populations boomed. Movement stretched farther across open land. The very land beneath was reshaped. Grasses held soil in place, preventing it from blowing away. They reflected more sunlight back into the sky. They pulled water from deep below and released it into the air, changing the cycle of rain itself. Grasslands were not passive backdrops. They were engineers, building their own weather and reshaping the planet's climate. Of course, this transformation did not happen overnight. Evolution is not a news headline. It is not an event you can point to in a single year. It is a rhythm, a pulse repeated over millions of breeding cycles, small changes compounding into revolutions. But by the later Oligocene, around 28 million years ago, the signs were undeniable. Fossil pollen tells the tale of grass spreading across continents. Chemical clues in ancient teeth reveal that animals were eating more C4 plants. The bones of those animals reveal longer limbs, different ankle joints for running across open land, heavier jaws, and new ways of chewing. The forest dwellers were disappearing, and runners, grazers, and chewers were taking their place. The early grasslands did not look like the endless prairies or savannas we imagine today. They were patchy, dotted mosaics of different habitats. Shrubby areas lingered. Wetlands came and went with the seasons. Groves of forest survived in pockets. But the trend was clear. The vertical world of the jungle, layered in branches and shadows, was flattening into a horizontal sprawl of open ground. Light reached the soil. Winds shaped the land. Fire became a constant partner, crackling through the dry seasons, returning year after year in an eternal dance with vegetation. And if you pause to think about it, the story becomes philosophical. This quiet, humble plant family with no brain, no ambition, and no plan was in the process of altering the course of Earth's history. Grass did not conquer with strength, or with speed, or with intelligence. It conquered with persistence, with patience, with the simple ability to survive where others could not, to make use of what others ignored. It did not just compete. It rewrote the very rules of life. It made room for great herds to thunder across plains, for burrowing creatures to hide in roots, and eventually for a strange lineage of apes to stop climbing trees, stand upright, and one day plant fields. But in that age, between 33 and 28 million years ago, humanity was far away in the future. The world was still in the middle of its grassy revolution, still adjusting to its new reality. Some species thrived, some vanished forever, some forests clung stubbornly to existence as small green islands of the past. But the direction was set. A plant had risen, a biome had shifted, and the earth itself had been conquered by something so ordinary, so invisible to our daily eyes, that you can walk across it without a second thought. Somewhere between 28 million years ago and 24 million years ago, evolution made one of its most quietly brilliant moves. It was not a dramatic event like a meteor falling from the heavens, or a sudden burst of monstrous predators conquering the land. Instead, it was a subtle change deep inside the bellies of certain mammals. The trick was simple but astonishing. If food is too tough to eat, do not change the food, change the gut. And from this quiet biological invention rose a group of animals that would one day alter entire landscapes, influence the future of human agriculture, and even affect the way carbon circulates through the planet's air and soil. These were the ruminants, the masters of patient digestion, and with them came a dietary revolution so effective and so deceptively simple that it would ripple across millions of years. This was not a noisy takeover. There were no flashing teeth, no great talons raised in conquest, no roaring beasts or trumpeting victories. The heroes of this story were animals with stomachs doing unusual things very efficiently. Their power came not from speed or strength, but from fermentation, from chewing the same meal twice, from letting invisible microbial partners do the hardest work of breaking down plants. If one wants to understand how the ruminant empire began, one must step back into a world that was already changing into something unfamiliar. By the time the calendar of Earth reached around 28 million years ago, the lushness of earlier ages had begun to fade. The tropical richness that had once covered much of the globe was slowly dimming, muted by cooling air and shifting rainfall. Antarctica, once green and wooded, had turned into a continent of ice, sending cold currents into the oceans and rewriting the way waters circulated around the world. Forests still stood, but they no longer formed unbroken blankets of greenery. They fractured into pieces, scattered by changing climates, unstable seasons, and the spread of open grasslands that were only beginning to creep into dominance. For an herbivore, this new world was not as generous as the one before it. It was no longer a buffet table heavy with soft fruits, tender shoots, and lush leaves. Instead, the plants becoming most common were stubborn, dry, and defensive. They included bark, twigs, and most importantly, grasses. Grass looks abundant and inviting, but it hides a cruel trick. It is laced with silica crystals and built from cellulose, one of the toughest molecules in nature. To most animals, grass is little more than green stone dusted with sugar, impossible to digest efficiently. Survival therefore depended on a new way to extract energy from this stubborn greenery, a way to unlock the nutrients locked inside the walls of cellulose. This is where the ruminants appeared. The mammals that belong to this remarkable group include deer, cattle, sheep, goats, giraffes, antelopes and gazelles, along with many of their ancient ancestors. What made them special was not simply what they ate, but how they digested it. Deep inside their guts were chambers that became tiny laboratories. Food did not just pass through their bellies to be broken down by acids and squeezed out into the blood. Instead, food was given time to be chewed, swallowed, regurgitated, chewed again, and fermented by the vast colonies of bacteria living inside. These invisible partners were the true magicians, breaking cellulose apart into usable energy molecules. In effect, ruminants signed a contract with microbes, outsourcing the hardest job of digestion to them, and in return feeding them a constant supply of plant matter. The result was astonishing. These animals became walking compost bins, mobile fermentation vats with legs. Their digestive strategy was not based on speed, but on patience. They were willing to chew and chew again, to let hours pass while microbes did the unseen work. This process is known by the technical term rumination, but for millions of years it was simply another word for survival. While other plant-eating animals fought in an evolutionary arms race of sharper teeth, stronger jaws and new chewing mechanics, ruminants stepped aside and solved the problem in a completely different way. Instead of endlessly upgrading their teeth, they built an ecosystem inside themselves. This changed their bodies. Their jaws were not designed to slice flesh or crack bones, but to grind endlessly. Their stomachs were not single sacs like those of most mammals, but complex systems divided into chambers. Their legs grew long and strong, perfect for roaming across wide plains and distant ranges in search of forage. They became animals of energy efficiency, not ferocity. And as they grazed, chewed and digested, they shaped the land itself. Their droppings fertilized the soil, their constant movement recycled nutrients, and their grazing patterns influenced the growth and spread of plants. What is especially remarkable is how early this transformation began. In the late Oligocene epoch, in the landscapes of Asia and Africa, the fossil record reveals the quiet beginnings of this digestive revolution. Among the ancient even-toed hoofed mammals, the aerodactyls, new branches appeared. Some of them were proto-camels with unusual teeth and bodies designed for life in dry lands. Others had already begun experimenting with multi-chambered stomachs. early versions of the system that would one day become the fully developed ruminant design. In riverbeds that have long since dried, scientists find their footprints fossilized in the mud and even traces of the gases they released, methane signatures preserved in sediments. Their teeth, when examined under microscopes, show distinct wear patterns that reveal a diet different from the fruit-eating and leaf-browsing animals that had come before them. No human hand guided this, no farmer bred them, no shepherd tended them, and yet the very digestive system that would one day give humanity milk, meat, wool, leather, and cultural traditions was already taking shape beneath the canopies of ancient forests and across the growing plains. It would take millions of years for this evolution to meet and merge with human history. But the blueprint was laid down long before the first person ever existed. The ruminants were never the biggest creatures, they were never the strongest. But they carried within them something subtler and far more powerful: metabolic elegance. Their system was a masterpiece of patient efficiency. Instead of a single stomach, they had 4. Each chamber had its role. The rumen was a bubbling fermentation vat. The reticulum sorted particles and decided what should be chewed again. The omasum squeezed out water and minerals. The abomasum acted more like a typical stomach, finishing the process with acids and enzymes. Together, this design formed a cycle. Food was swallowed, softened, regurgitated, chewed again, fermented more and refined further. It was a loop of recycling, an endless polishing of nutrition from the rawest of materials. It is tempting to see a metaphor in this design. Sometimes the most powerful solution is not speed, but patience. Sometimes the smartest way forward is not to invent new weapons, but to chew your problems twice and let hidden helpers do the hardest tasks. For ruminants, this meant survival in places where other herbivores would starve. They could thrive in dry grasslands, in forests where leaves turned brittle in the dry season, in alpine meadows with sparse vegetation. They could endure on low-protein diets, turn poor soils into living habitats, and spread across continents without waiting for perfect conditions. Their stomachs were, in effect, portable machines that transformed tough vegetation into life. This brilliance did not come in a single flash of invention. No animal suddenly woke up with a fully formed 4-chambered stomach. It happened gradually, a slow series of tweaks, mutations, and microbial partnerships. It was messy, like most of evolution, with many failed paths and partial experiments along the way. Yet from that gradual process, one group of unassuming mammals became ecological engineers. And while evolution often celebrates the big names, jaws, claws, brains, in this chapter the crown was won by digestion. By the time the clock of history reached 24 million years ago, ruminants had already spread widely across Asia and Africa. They continued to evolve into new forms, but the blueprint was fixed. From it would one day emerge the graceful giraffes with their towering necks, the swift antelopes leaping across the savannas, the sturdy gazelles, and the domestic cattle that would reshape entire civilizations. These animals would redefine landscapes, reshape diets, and even shift the global balance of carbon. It is remarkable to think that all this power flowed not from claws or cunning, but from the quiet ability to ferment grass. Between 5 million and 3 million years ago, in the wide valleys and basins of what we now call East Africa and South Africa, something small but world-changing began to stir. The thick forests that had once been safe havens for climbing apes were thinning. The trees that had once been ladders, shelters, and pantries were no longer enough. Life was shifting, slowly and quietly, in a way that would echo through every future age. And at the heart of this shift was a strange decision, or perhaps an accident that a clever ape made. Or maybe it was not cleverness at all, but desperation. Either way, this creature began to try something no other ape had truly mastered before. It began to stand. At first, this new posture was tentative. It was not the confident stride of modern humans. It was not the purposeful gait of the genus Homo, not the stride that would one day march across continents, tame fire, or shape stone. It was more like a hesitant experiment, as if nature herself was tinkering, testing, not sure whether this attempt would succeed. This ape was upright, yes, but unfinished, still tied to the trees, still uncertain. And yet, even in its rough, awkward form, it was a movement towards something utterly new. In the highlands of what is now Ethiopia, and in the low scrublands of what is now Chad, we have found scattered evidence of these experiments. The Earth has preserved fossilized bones, silent witnesses from millions of years ago, that reveal hints of this fragile step towards standing. The pelvis of Sahelanthropus chidensis, a creature that lived somewhere between 7 million and 6 million years ago, holds traces of upright posture. Not in a way that could rival modern humans, not even close, but just enough to suggest that this ancient ape sometimes stood on two legs. The skull of this species too reveals secrets. The hole where the spine enters the skull is placed in such a way that it seems designed for balance while standing. Their femurs, the long bones of their legs, carry tiny scars and markers, signals of tension and stress that suggest they sometimes bore the weight of a body balanced on 2 feet. Yet at other times, they still walked on all fours. They lived between two worlds. A little later came Aurorin tuganensis, found in sediments that also date back to those ancient millions of years. This species too showed signs of experimentation with upright walking, though like its cousin, it was not fully committed. These creatures were still in many ways apes of the trees, but step by step something was changing in how they carried themselves. By the time we reach Ardipithecus ramidus, around 4.5 million years ago, the evidence becomes harder to ignore. This being still carried a foot designed for climbing, with a big toe that diverged like a thumb, perfect for gripping branches. But its pelvis tells another story. The blades of bone had shortened and widened, shaping themselves into a structure that could carry the weight of a body moving upright. The balance of climbing and walking was tilting. Here was a creature not entirely suited for life in the trees, and yet not entirely adapted to life on the ground. It was in between, caught in transition, halfway between one world and another. The question that scientists have asked again and again is simple, but the answer remains elusive. Why? Why would these early apes risk leaving behind the safety of the trees to experiment with such a difficult and dangerous way of moving? Was it the changing landscape, where open savanna replaced dense forests? Was it the need to see farther, to spot predators or find food? Was it the advantage of freeing the hands to carry fruit, tools, or even children? Was it a way to keep cool, exposing less of the body to the scorching sun and allowing breezes to flow over bare skin? Or was it something else entirely, something we have not yet imagined? All of these answers are possible, but none of them are certain. What seems most likely is that upright posture was less about speed or efficiency, and more about adaptability. These early creatures were not choosing between walking or climbing, they were doing both. Their lives demanded flexibility, the ability to move across open ground but also retreat quickly into trees. Bipedality was not yet a perfected tool. It was a survival strategy for a world in flux. Yet once the architecture of bipedality began to take hold, it unleashed a cascade of changes that could not be reversed. The human body, in all its future forms, would never be the same. Slowly the spine bent into an elegant S-curve, balancing the weight of the upper body over the hips. The foramen magnum, the hole at the base of the skull where the spinal cord connects, shifted forward so that the head could balance directly above the body rather than drooping forward like that of a quadruped. The pelvis reshaped itself into a rounded bowl strong enough to cradle and support internal organs against gravity's constant pull. Knees developed the ability to lock, giving stability in each step. Ankles transformed. Feet, once curled for grasping branches, flattened and stiffened into platforms designed for carrying the whole body forward with every stride. None of these changes happened quickly. None appeared in a single neat sequence. Instead, they unfolded in patches and pieces, what scientists call mosaic evolution. Traits shifted in different groups at different times. Some lineages developed strong pelvises but still kept climbing feet. Others grew straight femurs but still bore long arms made for swinging. Evolution is not a tidy march but a tangled braid, a weaving of possibilities, and the fossil record from this murky period reflects that messiness. Bones are scarce, broken, scattered. Dates are debated, interpretations disputed. Many of the creatures we have found may be distant cousins rather than direct ancestors. Some may have been experiments that failed, evolutionary dead ends that left no descendants. Yet among this tangle, one lineage did continue. Somewhere in this long, uncertain story, traits converged in a way that would eventually lead to Australopithecus, the genus of the famous Lucy, and then, much later, to the first members of Homo. But for now, in these millions of years we are looking at, the story is not linear. It is a braided river with channels that split, rejoin, and sometimes dry out entirely. Walking upright was not just a change in posture, it was a transformation of life itself. It freed the hands, which in time would shape stone and later write poetry. It narrowed the birth canal, making childbirth more dangerous but also forging deeper bonds within early communities. It slowed down growth and stretched childhood, forcing young ones to depend on parents and groups for longer, which may have fostered richer social structures. These were not the reasons upright walking began. They were consequences, ripples spreading outward from that first experimental step. Evolution, after all, does not work from blueprints. It tinkers, stumbles, and improvises. And so, as we stand around 3 million years ago, we see a creature that is not quite us, but no longer what came before. It spends more time walking than climbing. Its world is drying, cooling, demanding new strategies. It is not Homo. It does not yet tell stories or carve tools of fire-sharpened stone. But it has made a choice, or rather, life has made the choice for it, to live on the ground, to walk on 2 legs under a sky where the sun beats more directly than the leaves can shelter. That gamble will shape everything that follows: fire, tools, migration, empires, dreams. But none of that exists yet. Here, in this moment, all we have is a fragile step forward. Someone stood up. Someone walked. Not far, not fast, but enough. Enough to begin rewriting the rhythm of bones, of birth, of life itself. Enough to make possible every future that would come. And yet the mind wonders, what if it had not happened? What if those early apes had remained in the trees climbing forever? What if the gamble of bipedality had failed? Would this planet still have storytellers? Or would it still be ruled by forests filled with 4-limbed apes who never left the branches? That is where we must leave them. Upright, uncertain, half-finished, but already carrying within them a seed of potential that no other creature held. Not yet human, not even close, but standing. Not with confidence, but with possibility. Somewhere between 5 million and 3 million years ago, an ape tried something strange. It stood up. It walked. That was all. And that was everything. This chapter of evolution was not happening in isolation. The same forests that sheltered the early apes were alive with birds, insects, and flowering plants that were also changing over time. Everything influenced everything else. Plants that produced fruit may have pushed primates to develop sharper colour vision so they could pick out ripe food. Shifts in the forest canopy may have changed how predators hunted and how prey escaped. Even the breaking up of forests, caused slowly by the movement of the land or by changing rainfall patterns, created little islands of habitat where different groups of apes faced different evolutionary challenges. What we are left with today is not a neat family tree, but rather a messy, tangled sketch of who was trying what, in which place, and for how long. Yet, despite the many gaps and unknowns, one theme stands out clearly through the haze of fossils. Walking on 2 legs did not begin on the ground. Many of the features we connect with upright walking, climbing vertically, flexible hips, and strong grasping feet, were already forming in the treetops. Standing upright may have first been useful for climbing up tree trunks or reaching for food, not as the first step toward walking on the open grasslands. This changes the usual story of human evolution. Instead of apes climbing down from the trees and then learning to stand upright, it may have been the other way around. They were already partly upright in the trees, and only later did some of them carry that posture down to the forest floor. The sad truth is that most of these early apes did not survive. For all their clever body changes and new ways of moving, most species of Miocene apes went extinct. Climate changes, shrinking forests, and competition with other animals better suited to the environment probably wiped many of them out. But a few lineages endured. Somewhere in Africa, most likely toward the later part of this era, the ancestors of today's great apes, gorillas, chimpanzees, and eventually humans, split away from this noisy, chaotic tree-dwelling experiment. And they did not do so as rulers of the forest, but simply as survivors of a long, confusing chapter that most people today barely realize ever existed.